Okay, now that we're straight and away, welcome everyone to the Tuesday, September 20th, 2016 version of the Keshe Plasma Reactor Group. As we gather again, dearly beloved, we gather here in the name of Keshe, somewhat, and we show and tell our devices and ideas based on the Keshe technology and other similar technologies, you might say. Okay, so I've only got something here I can briefly show to begin with, just for fun. I always like a bit of fun here, and this is something I found, was fortunate enough to find at the dollar store. It didn't come with the corks, I've got those extra. But even without cork, if we were to uncork it, which is probably better to show the actual design, which is this lovely piece of glassware. It looks like little lab flasks. There's 7 of them all together. And I wanted to show the configuration, which is very much our reactor combination, basically, with the 3 reactors and 1 in the center and on top, which would be like 1, 2, 3, and the 1 on top here. And then underneath are 3 more that are spaced in between the other 3 reactors. I thought that's a lovely combination. So I'm thinking with the right kinds of GANs in here, in a certain combination, it may be able to induce some rotation, perhaps into the top reactors, what I'm thinking. So I thought that's pretty cool. It looks pretty much equally cool this way too, but this way is especially good. Who knows, it could be the space reactor of the future. The problem will be I'll never be able to duplicate it because I have no idea where it came from. It's only got, what does it have? It has a marking. There's a marking. Yeah, it's some obscure marking, like, yep, it says 16. 26. One says 16, one says, wow, that's strange. One says 16, one says 26, one says, is that 3 or an 8? An 8. That's strange. And the other ones, I guess, have other numbers. There's a 22. There's a 28. A 10. I guess so. There's certainly a lot of them. And another 10. 2. So you know if there's a defect or something and so on, I guess. 2 of them come from the same mold 10, so interesting. So each will have its own individuality just from the mold in a way. They aren't all from the same mold, you could say. Okay, another little fun thing that I found, which is these very small, they're called mini martini glasses at the dollar store. It's like $1.25 for 12 of them. So I couldn't resist, of course. But they've got a nice shape that you could use for certain experiments. And what I was thinking of was I want to create, similar to what I showed last week on this device, the Tesla twin, was it called, biconical coil. It's called the football coil, actually. Tesla called it I guess Tesla didn't. I don't think they had football then. But somebody called it the football coil. I think football was invented after Tesla, as far as I know. Soccer they had, but not football. So anyways, I glued one of these martini glasses to the other one using some acrylic glue. And now I can create that same shape as the football coil. And I can wrap copper wire. What I expect to do here is wrap copper wire around this in a spiral this way, and then spiraling down the other way, so that it'll be a copper wound coil from one end to the other, and I'll nano-coat it as well. So it'll be like a nano-coated copper cage, you might say, for the interesting stuff going on in the inside, which I hope to fill it with certain gases and perhaps even a electrode in the middle, I'm thinking, or a wire coming in, nano-coated wire from each side with a gap in the middle for a spark gap. Anyway, just some current ideas that pop to mind in a little trip to the dollar store. These are not real tough. These are not really tough items. It's definitely not polycarbonate, and if this gets rotated at high speed, it'll come apart and shatter, no doubt about it. But it could take low speed rotation, and it could take making just the plain coil out of it, maybe setting this as part of a plasma capacitor setup. Okay, that's a little bit of show and tell. I don't have much else in terms of projects. I've got some more bits and pieces I've picked up recently, but nothing too significant, I guess. One thing that's kind of interesting I'll show, which is this. It's hard to see because it's so black, and it looks very much like our nano-coated copper wire, but in this case it's called black steel tie wire, and it's sometimes called mechanics wire. You can see the same thing in that, and I believe it might be a nitrogen coating process with and they give it a black oxide coating, which is, it doesn't come off, well, not very easily, and it protects the steel from rusting, and it's black. So I thought that was interesting, and I thought, well, what if this became a core for a coil, a toroid coil? It's already essentially a nano-coated core, but it's iron or steel, of course, but it might have certain qualities when you know, wrapped with nano-coated copper. I think there's something to the idea of an iron core. I don't like regular iron wire, though. I think it should be nano-coated in some way. So I thought this might be fun to try and see if it makes any difference, maybe compared to a regular iron core, or just for the heck of it. I mean, we know a toroid with an iron core will tend to, you could wrap copper wires around this side and around this side, and you could have current coming in here, and you would get current going out of the other coil. If you wrap twice as many wraps here, then you'd have half the current going out but twice the voltage, and so on. So it might be possible to use something like this to use as a kind of a plasmatic transformer, where you can take off different voltages with different nano-coated wire covers that are or coils that are wrapped around this in various places in various amounts of wire, various numbers of coils. Anyway, that's just something that came up. I'm cruising around Princess Auto. I just can't resist some of these things that look like they could be a plasma reactor in my mind. People have no idea what's going on in my mind as I walk around in these places. Well, some do, because I've told them. Like the guy at the there's a radio controlled car place, you know, these little radio controlled cars that the kids have these days. Well, there's this older guy. Well, he's older, he's a year or two older than me, but he's older, and somehow he remembered, well, I guess it was a bit of a surprise to him, he remembered me from last year when I went in there. I just went in a few days ago, And he remembered me because I had talked about this plasma device. I needed some bearings and the shafts and so on that were part of all these car parts, and I was going through all those car parts, and he just loved it because it was something different other than just the same old car parts, that these little cars that with the motors and so on. You can, it has all the accessories and all the parts on the walls, but it's, you know, kind of boring in a way if you're not having something new come in. So this whole plasma, rotating plasma, yeah, I want this rotating plasma globe with, I need the bearings, and you know, I thought these 8mm bearings would work and so on. And it got his attention. He remembered me from last year, and, oh, you're the plasma guy, aren't you? Yeah. So he sat there and talked to me for, you know, close to an hour, and just told me all about his life and all about the changes he went through and all this kind of stuff. It's quite interesting, actually. Sometimes when you do unusual things, it can give you inroads into people's lives that normally they wouldn't open up and talk about. So I'm sure lots of people find that when they start talking to people about their plasma devices and technologies. Okay, enough about me. I've got something I want to present here first before we do others. And you see, I have to do a screen share here. And let's just get this lined up. Okay, here we have an image from someone that's trying to make the CO2 gans. Let me see, they mention, hi Rick, it was a blessing to receive your message this morning. My health is falling fast as I'm still trying to produce a quality GANS product for the pain and for a cure for my B-cell lymphoma. She says, I will send a picture of the most recent set of CO2 GANs that I tried to make. We didn't use any current other than the 2 copper wires connected and creating their own current. Zinc and a nano-coated copper plate. So what's happening here is this person is trying to make GANs to help their health condition. And they made an appeal for someone to send them GANs and so on. And I recommended that they really try their own, because I think that's the best way for people to create the GANS product themselves, the best way to go about it for their own health purposes. Anyway, they've got I don't want to say the person's name because I don't have their permission really, but I can just say they have a week and a half before the doctors want them to start the chemotherapy, and they'd like to find a solution before that time. Well, of course, it's pretty difficult to just have an instant solution at this point in time, but a lot of people are reporting good responses with the GANS water products and the GANS patches and so on and so forth. So I just wanted to give this person some advice on creating the CO2 GANs for themselves, and they sent this picture basically, and I wanted others to help me we'll diagnose this situation, try to figure out from this picture how can their CO2 operation, CO2 GANs production be improved, and what do we see that might be obvious that shows that it's probably not going to function too well, or maybe low production, or maybe it's going to be too much of this or not enough of that or whatever. So I'm just looking for input on that. I've got a few ideas myself, but before I prejudice anyone, I'd like to get some input from those who know, which is many people involved with the whole plasma reactor group, of course. It's the basic thing, CO2 GANs. I'm just having trouble with my sunflower here for some reason, John. Just a second here. Let me see. Let me try something different. Okay, I show. Okay, why is my voice coming through? Okay, let's just. Okay, I gotta check my settings back and not to stop the screen share for a second just to check my settings. Okay, I think we're gonna be better now. Let me just do one other thing. Okay, you want to give me a sound check again there, John?
Checking it again. Little lights are jumping up and down.
I'm not
Apparently
hearing you for some reason. Okay,
Check.
We're trying.
Yeah, I can't hear you, so I have to go back to the headphones. Yeah, I can hear you through my built-in headphones, and then I go to Soundflower, and I'm losing the audio. Let me try to add it as a source again.
You need fertilizer for your sunflower.
Now I don't hear you, but I can hear I can see it on my live stream. So it's going through in the live stream, but not.
Oh.
I don't understand. Let me see. Maybe it's my audio.
Audio.
Let me try to change the audio. Ooh, well, mine's working, but yours isn't. This is not good.
Well, it's kind of weird that it just sort of died all by itself.
Yeah, I think. Yeah, I'm not. Okay, now I can hear it. Now I can hear again. I wasn't hearing any of that. I think what's happening is I upgraded to the latest operating system, and it probably bumped out the Soundflower, made it no longer work. That's what I have a feeling. Let me see. Let me try to just restart I quit and restart the line in. And oh boy. Okay, give it to me again, John. Funny. Okay, now I can go to switch to Soundflower and see if it works. Now I can't hear again.
To Soundflower. And we're adding fertilizer for the sunflower.
Okay, what if I... try...
You gotta get it fixed, Rick. You got a host for tomorrow night.
Okay, back to...
Oh, if you didn't have a Mac, I could fix this problem in 20 seconds.
No, I'm having trouble here, so I'm going to have to do something different. See what I can do. I think it produces an echo in live stream. I can just have my audio go live on my headphones. Try to output it to the live stream. That'll probably be tricky.
Okay, that was it works. Well, I can hear me now.
On live stream or
No, coming through on your microphone.
Right, that's where the echo comes in. If I keep my... Try talking now.
Try talking now. What do you mean try? I'm really good at it.
Okay, well that's working as long as I keep my microphone off on live stream while people are talking. But then they won't be able to hear me on live stream until I turn my microphone back on. Then they can hear me in live stream. Okay. That's complicated, but I'll try to deal with it. I'm going to have to find a solution after the workshop. This is going to be annoying, I think, but we'll give it a go. Okay, let me just... Well, it's complicated, but we'll just have to deal with it. The sound may not be the best on live stream, and might be just the way it goes. Okay, I'll find a solution later. Okay, so where was I? I was describing this picture. Let's go back to that because I stopped the screen share.
Yeah, I was just mentioning that the zinc plate on the top looks like what we would expect to see off a zinc plate. The copper plate on the bottom, I don't see any evidence of nano-coating on that plate at all. It looks just like a dirty piece of copper.
Yes, that was exactly my first observation. Yeah, go ahead.
Yeah, also the volume of zinc and copper in that bucket, the bucket is way too big. These pieces of copper and zinc, they're good for maybe a 1 liter or a half a gallon of solution. I wouldn't go any larger than that.
Yep, good observation. Yep, I'd say that the copper plate, although these look a bit like the ones in the CO2 kit, but I would have thought if they had the CO2 kit they would have used the plates in there. They're pretty small plates to start with, and it looks like the copper plate hasn't been properly nano-coated. It may have had a bit of nano-coating on it. Maybe it was fire nano-coated just very thinly or something like that. And that'll come off quite readily in the salt water over a period of short time.
Yeah.
And also, go ahead.
Even if the nano-coating had come off of that plate, around the edges, on the corners, you'd still see evidence of deep black. And I don't see any evidence of nano-coating on that plate at all. Well, so I think the first step is teach this lady the proper nano-coating techniques, and the rest of it's really easy. I mean, there's virtually nothing to it. You know, a quarter cup of salt in 3 cups of water works pretty much everywhere. And if you have raw copper, don't let it touch the water. That's basically all you have to do. Everything else is really easy.
Yeah, and I'd say it looks like the salt concentration is too strong to build up on the copper plate that way. I think what happened was they probably had the original height of the water at a certain height, and then as the water evaporates, because like you say, it's a fairly large bucket for the plates, looks like the plates are only in maybe halfway, or else the water evaporated. And if you don't replace the water with just plain distilled water, not salt water but distilled water, then the salt concentration will build up. If you have half of the level of water that you started with, then that'll be double the salt concentration. So
yeah, that's why we use tall, thin containers. It limits the amount of surface area exposed to the air, so it doesn't evaporate as fast.
Right, right. And so what happens is if the salt gets too concentrated, that'll strip off the nano-coating very rapidly on a copper plate, And it can give fast GANs production that have higher salt concentration, but you've got to really watch it because it's easy to eat into the copper, and then you're starting to produce copper GANs when you're not meaning to, and so on. You don't want to contaminate the CO2 GANs with the copper oxide GANs unless you deliberately are trying to do it that way.
If she's having problems with it, she could try the carbon or the graphite with a real low, like half-amp charger. And her,
Yeah, I don't know if she has enough time to do that. One technique.
Works really fast.
Oh, it is really fast. I totally agree. One technique that came up on Facebook just was it yesterday? I think it was yesterday. The individual, he created a nano copper coil along with his plate and used that. He just slipped the zinc plate up in between two of the winds of the spring that he had made, his nano-coated spring, and his nano-coated copper in the other end, and submerged the entire thing in the water. And he said he was getting really fast results out of that. So that's something I want to test as well. And that would be quick and easy to make. If you're nano-coating anyway, it's just a matter of winding up a quick spring and nano-coating that too. Run, Rick, run!
Hard to run when you don't have a knee.
Yeah, but it's a lot easier when you're not wearing headphones.
Yep. I was, let me get my live stream up here and get the video back for a minute. Okay. Yeah, I just wanted to show also one way to create fast GANs is to use these Brillo type pads, but you have to get the real copper ones. There's many lookalikes and others that of other types of materials and so on. I've got lots of them. Pretty much bought them all. Some of them are fake. You can tell with a magnet. If a magnet attracts to it, then it's steel with a copper plating. If the magnet doesn't stick to it, then it still could be a zinc with a copper plating. So there are lookalikes with these things, but generally if it says copper, like and it's one of the higher quality ones, then it'll tend to be real. The ones in the dollar store are not always, not even often, the real copper. So what happens is with one of these as an electrode, when it's nano-coated, nano-coats quite quickly. You just need vapors, and it's almost overnight, but if you leave it a few days and the vapors, like just take a baggie, spray it with a bit of caustic, poof, and it's done. Set it out in the sun for a few days. Then once it's nano-coated, you put that in with your zinc plate, and it will rapidly produce GANs because there's so much surface area in these things. So the downside is if you do several coatings of the nano-coating on it, the pieces may start to actually break off if it's in the copper too long and it's too much nano-coating process going on. So that's what I've heard from Douglas, I think, mentioned that.
Yeah, the other downside with using those, they do work really good. I've used them before. But if they get contaminated or the nano-coating starts to bugger up, they're basically done. Toss it out, start again.
Yeah, yeah. But I think if I had to make fast GANs, that's probably the way I would do it. I don't know if I want to run electricity or not. I'm a little hesitant on that process. So.
Yeah, well, I just did a batch of CO2 with electricity, but I used carbon rod and zinc. And the zinc encircled the entire circumference of my container, which is about it's a tall half-liter round container. And the zinc rod was hanging right down the center of it. And I hooked it up directly excuse me, to a 5-volt old 300 watt computer power supply. Negative to the carbon, positive to the zinc, and ran it overnight. And the GANs I got is gorgeous, absolutely beautiful.
Now, is that, you think that's CO2 GANs or is that zinc oxide GANs?
It's so fluffy, it's ridiculous. It's just like my really slow CO2 GANs, except for it's whiter. It doesn't have that very, very slight blue tinge to it, but it looks just as fluffy and just as beautiful as all the rest of it. And the zinc looked perfect. Like the zinc looks like the day I put it in there. There's no degradation on the zinc at all.
Really?
Yeah.
Okay, that's surprising.
So, what was your amperage and voltage?
5 volts and whatever amps it worked out to be. I just hooked directly to the 5-volt rail of an old computer power supply.
If you go back to her picture, you also see that she has a little wall wart power supply in that picture, and you can see an alligator clip.
Yeah, but I think she mentioned in her email, if I remember right, Rick, that she didn't use any electricity in this batch.
Yeah, that's the way I understand it. Sorry, I'm live streaming. That's the way I understand it. Yeah.
Yeah, using the nano copper with electricity is really fussy, but it appears that with the carbon rod, it's nowhere near as fussy. You've got a wider range of error that you could run in.
Okay.
Yeah, I was going to say, I ordered some graphite rods online like 6 weeks ago, and I never got them. And I was trying to show actually the bass player that lives next door to me how to make the GANs, and I told him I was waiting on the rods, and he was scared to nano-coat and blah, blah, blah. So we were walking, and he said, hey, what about these pencils? And I think this is not the same one. And I thought, well, I've heard, the pencil, it's too soft, graphite. But I said, well, let's try it. So we bought some pencils, and I carved off, it's a very, very thick pencil lead. And he took an old telephone charger and cut the wires off. I gave him a piece of zinc. And I've used it. I used it just now to make some CH3, some of this pencil lead. You do see some of the lead, coming out. It's okay. You can see it in the white GANs, so you can sort of get rid of it more or less. You do get some bleeding in there, but man, he attached the charger, used the pencil lead and the zinc. I've got it here. It's a huge, fluffy. I don't know. He got 40, 60 milliliters.
Can you show a picture or your video there, Mario?
Yeah, here, I'll show you the GANs. Okay, let's start my video here. Just a little pencil. I don't know if you can really see how thick the lead is. This one I bought at a different place. It might be a slightly smaller one. I didn't use it, and I cut up the other one. So this is 2H, whatever the thickness is. But this is the GANs. I mean, that looks like CO2 to me.
Did you see any degradation of the zinc plate in the combination?
I think he still has it. I think there was some, pretty typical. I might even have them. Let's see. I had to step away for a moment, but has anybody taken apart a D cell and got the carbon rod and the zinc out of that?
I was visualizing that today, Denny. I visualized cutting the bottom off, taking all the guts out, and visualized cutting the top out and taking out the carbon rod, and saving all the guts and using the zinc and the carbon rod to make the GANs. So I'm thinking, whoops, I didn't have my live stream on. I should recount that. It's kind of interesting, actually. Just a minute there.
I heard what Danny said. Can you say that again? Repeat.
Yeah,
that?
let's go through this again. Let me just get things pinned and so on here. Okay. What'd you say again, Denny?
Well, you get a D-cell battery, you know, the ones that fits in a flashlight, the larger battery. I
Right.
think that's a D cell. And so you take it apart. There's a carbon rod that runs down the middle, and there's zinc. There's a zinc liner. Those two working together get you the CO2. And there you go. Somebody has done it.
Okay, that's Mark. Well, we can have a look at his stuff there. Yeah, well, think about it. This is an amazing idea. I mean, these D-cell batteries are all over the world. We throw them into landfills. Well, under a survival situation where you need to get some CO2 GANs, you got nothing with you but a D-cell battery, you could actually cut it open, get the electrode out, get the zinc out, start making your own CO2 GANs, use the guts of the battery to the electrolyte to start making plasma capacitors with it, and you could use the rod and the outer casing and so on as well as part of the experiment, and you could actually create perhaps a reactor and health products right from a D-cell battery.
One of the things you're forgetting there, Rick, is that you're going to need a little bit of power. Did you say go ahead and use another D-cell to power
Well,
that?
that's the other thing about it too. You could actually use another D-cell to power the D-cell that you take apart, you know, and so on.
Does the D-cell have zinc also?
Yeah, it's got a zinc liner, like was mentioned there.
Okay.
Could I ask a question?
Mm-hmm.
Because I cut these small ones on the 6 volt, the 4-banger with, the big chunky square ones. These carbon rods are inside those ones that are, they go on a flashlight.
Right, the big flashlight, what do they call it? 6 volt lantern battery, it's called. Yeah.
Yes, exactly. And I got a whole bunch of them, because you can get those anywhere, and they're only $6 at any place. But we had this discussion before, I think, and I asked about that because these are packed in the zinc, but they also have that the battery acid. This is all when you cut that. I have a video of it. I showed how I cut them in half, and you can pull these out. And there's a small zinc cap at the end of it. You got to twist that off to get them out. They'll break real easy if you're not careful. But then everybody said, well, these have been soaking in the battery acid or whatever acid they use to make that battery, and now that these carbon rods are contaminated.
Well, I brought that up because it's not an acid, actually. It's an alkaline, and that's why they're called alkaline batteries. And
Yes.
I wasn't certain whether or not that the alkaline material that they're using would get in there and contaminate your gas. So when people were thinking about this, I suggested, take your rod out, dry it completely, wash it as good as you can, and then abrade it. Take some of the material off of the outside of it with sandpaper to get below any of that contamination or reduce any of that contamination that may be present.
Yes, and then we went farther than that, and then Armin said that when you do that and you want to use these particular rods like that, when you the abrasiveness, he didn't suggest. He said you should only have one abrasive and one non-abrasive, because for whatever reason, that's what I mean. If we go back into the,
I'll tell you why, Mark. Okay, what he does. He makes a CO2 GAN using 2 rods. He takes one rod, and of course you wash them in your distilled water or deionized water, and you then burnish one with a Scott-Brite pad. Do you know what it is?
Yes.
You know what those are? Those green pads that are there, and so you clean it and burnish it. That way, you've got one that's and the one that you burnish, you put on the negative. You put the
That creates the hills and valleys.
Yeah. Well, actually, I don't know if it creates it or not. It slicks it up.
Oh, it smooths it out. Okay, you're right, Danny. Yes. The other one is all.
Yes. So, but I think if you wash them,
because these I washed, you know, when they come out of the battery, when I first pulled them out of the batteries, and I didn't, you know, like John said, they might be contaminated. So what I thought was, my thought process to clean these is to bathe them in baking soda first, and then cleanse them in vinegar, positive and negative, and then just wash them in distilled water. You know, I let them soak in each one of those materials, you know, a couple days for each one. I thought maybe, you know, I don't know how porous carbon is, how deep that acidic or whatever, or the alkalytic solution they put these in, how deep that goes in there. How porous is this? You know,
you're also going to end up, when you're using your salt water, you're going to end up washing that gans as well. And so in the process, you're going to have fairly clean CO2. Your CO2 is going to, and then you're not using the gans itself. You're using the liquid plasma off of it. You're using the water that say on the 7th wash or the 6th wash is now you don't have any salt, and so you've done a fairly good job of cleaning all the way through the process. And so my particular point of view would be that you've got a good liquid plasma.
Well, that would be for, you know, like Rick said, in desperate times. That's the way to, I think, would be to cleanse these. We really need to get some gans going. Then the next step was, like you suggested, these are those gouging rods.
Yes, those are from a welding supply.
Yeah, and they had the copper coating over it.
Yeah, the copper sheet. You took the copper sheet off.
Yeah, and the easiest way to do that was I just took a file along it, and I just went along the really nice nano coating, and it gives you a lot more surface area. I think that's what we really look for surface area here. Oh, there it is. Here, let me show you. This came out of this here stuff came out of this up here, because I changed it out, and here's the stuff that comes off that gouging rod. You know, it's like a foil.
Yes, it is. It's a heavy foil.
It's a heavy foil. And then, like Rick said, you know, these scrubby pads, if you wait too long, they get burnished. They look. So now what I do with these, and I go to the next step, I'll take these and put them in caustic. So then they become nano-coated, and I'll get a little bit more life out of them. You know, you lose a lot of you don't really want to leave these in there too long, because all of a sudden they'll break down, and then it gets on the bottom. You don't want all that copper mesh stuff breaking down and getting into your GAN solution, because then you got to wash it out. It's too hard to get it out. I just change them up. It out. I called the manufacturer, but if you go to your local hardware store, you can get them. You know, I'm not trying to, but I know they're. Pardon me, John?
Too late now. We already saw this, the brand name.
Oh, sorry. I try to really block out the brand name and just kind of let them smile.
Back to your gouging rods. I tried the rod with the carbon and with the skin off, with the copper sheathing off, and also with it on. And I find that even with the sheeting on, it gives me excellent results. And so it's not really necessary from my point of view that you take the sheeting off.
Yeah, you're right, Denny. There's a lot of different processes we can use to do this. It's a personal signature, isn't it? But yeah. I just, I don't want to take nobody's time up here, but I want to just make one suggestion to Rick's friend, and I know they only have a short amount of time, but really they have time. If they have the will, they'll have the time. And I thought, like Rick said, and everybody should, it starts from the very beginning. And I take the salt. I don't care whatever salt you want to use, but I used that Himalayan sea salt. I put my feet in it because you want to be connected to every single thing you start with. And the salt is the very first thing we use to start to break everything down. So I thought, and this was one of the very first things I remembered from Mr. Keshe's wife. She said, if you want to be connected, connect yourself in the very beginning. And I thought, what is the beginning of this? And the beginning is the salt process to break it down. And the exit part of our body is our feet. So what I did was I just got, I made a foot bath of Himalayan salt in hot water, the hottest water I could get. And I did that for 4 or 5 nights till I got 5 gallons of water, or 5 gallons worth of this Himalayan salt. I used 2 pounds unrefined, non-touched Himalayan salt, and I would just dissolve. So the foot bath only takes so much, and then you can only dissolve out of the 2 pounds. It takes about 5 days, maybe 2.5, 3 cups a day in the foot bath, and you just let it, go until it, you hot as your feet can take it, because it's going to take out of you your stuff. Everything of you is coming out of you in that foot bath. And then you're going to make gans. And then you're going to put your blood, a drop of your blood, and it's going to say hello. And everything, it goes from there. It's a building process. And to make gans, Rick, I hate to tell your friends, but I don't want to say hate, but I just want to tell your friends, it takes about 30 days to make a good gans. And you're not going to need a lot because it's going to be pure. It's going to be yours. It's going to take a little time. It's a slow process, but and I, like some people use these carbon rods for CO2. I just use zinc plate, and I nano-coat a zinc plate. So it's just the purest CO2 you're going to get. Zinc on zinc, copper on copper, carbon on iron. That's the basics. This is the start. This is how you start it. And the salt starts dissolving all that stuff. And if we really look close, and I learned, Rick told me this way, long time ago. If you see salt up here, you get the stuff. You're letting your water go down too much, but you kind of want the salt where the connection of the two from this side to this side. When you have a nano-coated wire, I have no power. It's just a nano-coated wire.
Could you show, when you say this side to this side, we're not seeing side to side there. We're just seeing your jars. Ah, now we see the finger. Thank you.
See, can we see the salt deposit from the wire to wire? And it only starts, no place else. I have no other salt. Remember, Rick, when you first yelled at me, you said, oh, you don't want that salt deposit on everything. You're letting your water go down too far, and your salt's too high. And so I controlled all that, and I figured out, like John said, you do, what's the ratio, 1 to 3?
I'm using about 8.3%, which is a 1/4 cup in 3 cups of water.
I have it written down. I have so much stuff written down. But anyway, my containers look a lot better. And the only part of the salt deposits are where the connections are made. Like this is really heavy right here with salt deposits because of the connection. It's salt is making the electrical connection. You can see it through each and every one. As I go down the line, there's a little bit more salt, and that nano-coated wire just goes from here to here, here to here. There nowhere else it's connected. It just goes, you know, I got a nano-coated wire to hold everything. So there's one here, nano-coated wire here, 14 gauge, and then it's just a yeah, it's that stranded wire, this stuff, that goes from side to side. I think it's 18 gauge, to tell you the truth. And that just makes the connection, but it is nano-coated. So your friend, anyway, I think the salt is the most important thing out of all this process. Agree or disagree?
I think that's pretty important, but you have to have the nano-coated plate too to start with. I think that was her main problem, is not having an adequately coated copper plate.
Yes.
Yeah, well, I'm working directly with the fella in Singapore, and basically on the other side of the planet from me. He's more or less right on the coast. I'm well inland, and if I use his salt concentration, my systems don't work. If he uses my salt concentration, his systems don't work. So there is a little adjustment that you need to work with the salt. Like for myself, 8.3, 1/12. A quarter cup and 3 cups, half a cup and 6 works really good for me. But Vivek needs a stronger solution where he's at. Not really sure why. So don't assume that 8.3 is actually accurate everywhere, because it's not going to work for some people. You'll have to make some adjustments for that. Some people, they need higher. They need 12%, 14%.
Breaker.
Come in, Breaker.
It's kind of interesting. When I did all of my ganses, I salted to taste. Being that I'm not a mathematician in any shape or form, I decided that that would serve me well. So I add salt based on taste. When it gets really salty to my taste buds, everything's good to go. And I've had no problem developing whatever gans I'm after.
Yeah, like Mr. Keshe says, there's many ways to do this as there are stars in the sky. So
yeah, I do the same thing. I taste the water, because I grew up on the beach. I remember the taste of seawater, and when it tastes, it reminds me of the seawater about. But I found I had to use more salt here than when I was in Thailand, or it's the other way around. I think it's the other way around. Now I can't remember. So yeah, the salt definitely matters. But I tasted for the salt water, for the sea salt, you know.
Yeah, and the different kind of salts change too. Your regular iodized white table salt actually tastes saltier than the gray Himalayan sea salt. The pink stuff, I've got a jar or a bottle of pink stuff in a grinder. It is incredibly strong. I put a little tiny bit on my food, and it's almost too much. So the quality of your salt, the makeup of the salt is going to make a difference as well. There's a lot of variables to think about in this.
Breaker. So this is Denny, and I'm going to go back to the carbon rod. The carbon rod I found uses less salt. I also use an aquarium bubbler in the water, and that helps circulate my water too. And it was interesting to hear what you found out about the when you use that zinc plate and the carbon rod. One of the first things it does, it clings onto the walls. Isn't that what you said, John?
Well, no, I used the zinc that I used. If you can drop your camera down, you've got the same little round containers that I use to make my gans in. His storage containers, I used the exact same device, same units. And when I did my last test with the zinc and the carbon rod, my zinc completely encircled. I made a ring of zinc that fit down inside of that container.
Do you punch little holes in the top, John?
I don't put the tops back on when I'm making my gans.
Oh, I see. Well, I put little holes in them, so you can just insert like if you wanted to just put, you know what I'm saying?
Well, I'm of the opinion that you're dealing also with a gas transfer from the atmosphere, because that was one of the things Mr. Keshe brought up, that when we make our CO2, we're actually cleaning the carbon dioxide out of the atmosphere. So I do want a gas transfer on the surface of my solution, which is why I don't cover it anymore.
Okay.
Yes, I used that carbon rod in a 40-gallon tub. It was huge, and I got good production out of it. I found also that the lower the milliamp, the fluffier the gans, and I don't go. I mean, when I say low, I'm down there in the 20 milliamps and the 10 milliamps. Just you can barely produce a fizz. I go down to where I barely produce a fizz, because that's what it does. It fizzes around the rod.
Mm-hmm.
And so I go down to where I can barely produce a fizz, and that way I know that it produces real fast. Okay, so sometimes I don't care how fast I produce it. I'm not in a rush, so I'll go all the way down to a small fizz. Now, when I have found that what was it? Well, anyhow, the bubbler works. I'm going this side out. Over.
Yeah, when I did my carbon GANs, or my carbon and zinc to make the CO2 GANs, even with the computer power supply at 5 volts with whatever it supplied it, I didn't get an electrolysis effect. I didn't get the bubbles. I was actually quite surprised that I didn't get the bubbles. But
you got no fizzing at all around the rod.
None at all. I got a white slime that built up around the top of the rod, right at the surface of the water, but there was no visible bubbles coming off of the carbon rod itself. And my zinc plate looks like same as it did when I put it in. It's not pitted, it's not degraded.
Yes, I would run that experiment for a month and a half, and I'd still have some plate, but I moved it away from my rod quite a bit, and my plate was fairly large. My first attempt was that it ate up the plate.
Yeah, if it's eating up the plate, something's not balanced in your system, because you're gonna be getting if it eats your zinc plate, you're getting the zinc oxide.
Well, yeah, that's exactly what I wanted. I mean, I want a solution that's zinc oxide. I don't want a solution that's more. So it was kind of like dial in. What do I want? A 50% to 75%. So I played around with that. And so, but if I was to advise the lady that and she wanted to produce CO2 gas quickly, and she had carbon rod, I would give her that, because any CO2 gas done is better than no CO2 gas, and she gets right, and she uses the plasma water. Now she can use the plasma water several ways. And Rick, you put up a drawing last time of how to use these different things. It was a chart. Do you still have that chart? Because it might be of interest to her.
Yeah, Rick may have trouble getting back really fast. He's got a computer.
Sorry, which chart was that again? On what now?
It was the basically the liquid plasma health chart.
Oh, right. Okay, thank you. I'll have a look for that.
Because that might be something that she could use. And another thing is, does she have any friends nearby? Does she have somebody that's nearby that can help her?
Well, she does live on Vancouver Island, which is where I live, but 100 miles away or something. But there are people on Vancouver Island that might be able to help her as well.
Yeah, I meant just down the block.
Yeah, down the block, I don't know about that.
2 or 3 miles away. 100 miles is pushing it a little.
Mm-hmm.
Yeah, I think something we should stress for most of the people listening with this is that if you're making CO2 GANs and you're going to be using it primarily for health devices, you want a little zinc in there. So don't worry about all of the like, we go overboard trying to get pure CO2. We're also working with significantly different types of technologies. If you're just doing the health devices, a little zinc in your CO2 is actually a good thing.
The zinc oxide is amazingly good healing properties when you look up just plain zinc oxide. I mean, here it is. I was listening to the CBC News here in Canada. We have the CBC News and the National, and they put ads on the online, news. I hate it, but this ad comes up, and it's this baby butt. It's like, oh God, couldn't they direct their ads to people that have kids at least? No. In this modern society, normally we can do that. Anyway, so I got this baby butt in my face, and they're sprinkling this stuff on and so on, and they say directly, this is zinc oxide, and how proud they are to use this zinc oxide as the solution for this rash problem and so on. I thought, wow, and they not only said zinc oxide, they said zinc oxide nanoparticles, nanoparticle, I think is it nanoparticle or nano-technology perhaps, I'm not sure. My mouth just about dropped. I couldn't believe they were...
So I take it, Rick, that you've never had zinc oxide cream in a tube. That have you ever... out that white stuff that gets all over the thing.
They use it for various afflictions, and like for sunburn, for example, or prevent sunburn, perhaps, and so on.
Yeah, I put it on my baby's butt years ago.
And
that was diapers rice. That was before they had that's when you had the cloth diapers as well. And the thing that it was for primarily was it was like a waterproofing. In a sense, because when and so that's
well, it's very good stuff.
I don't know if it was if it was a good thing or a bad thing, because back then you only did some of this stuff out of ignorance.
Well, they've tried. Pardon me, John, say again.
45 years ago, when I was growing up on the farm, we didn't have antiseptic. We had a little bit of Watkins salve, and we had ozonol, which is basically zinc oxide. And I grew up on that stuff. It was normal. Everybody knew what it was. I'm flabbergasted how we could lose something that amazing in that short a period of time.
Well, it's interesting, and now the European agency that deals with nano-materials and so on, they're trying to put regulations in for all the nanomaterials, nanoparticles that are in the environment. So they've tried to nail zinc oxide, and yes, it is in the environment, and yes, it's pervasive all over the place. But they couldn't find anything really detrimental to it that I could understand. It doesn't seem to adversely affect most anything. In fact, it's beneficial to most stuff, so not sure if there's any issue there directly. It's sort of like the CO2 GANs. It's kind of hard to do wrong with the stuff in a way.
Is your participant the lady? Is she on Zoom? Can she talk to us?
I don't think she's on here. No.
But will she be able to look at this particular?
I will suggest it to her and see if that is something that she can access.
Yeah, she'll be able to read this chart and get an idea. Because
I could send her the PDF. Actually, I contacted through email. She sent me an email, so it might be her only way. I'm not sure if she's into the online thing, but I will check. Send the PDF. And,
you also send her how to make GANs. She's making GANs right up here at the top.
Yeah, it appeared from the picture that she needs help with nano-coating, not necessarily the gans making. She needs her process adjusted a little bit.
Yeah.
But
So
looking at that piece of copper, there was something wasn't right with the nano-coating.
yeah, it's like Mark said, start from the beginning, get your salt the way you like it. For your salt water, make certain the actually nano-coating the copper is important, and a lot of times that nano-coating the copper, I still got copper that I'm nano-coating that I've had out there for about 8 months that is aging because
John,
Yeah, I just
John,
go ahead.
Hamburger.
Go ahead.
John, you might want to do a quick go over of your cold caustic bag system. That would probably help her a great deal with the caustic coating.
Yeah, I've got a full-on instruction video coming up. We're going to be starting on the 29th and doing a weekly program. It'll be out about a month later after that. So it's a little past this, but there's lots of videos out there about nano-coating. And Rick, it would be easy to describe in the email. Just put it in a baggie, spray in a...
That's exactly what I was going to reply. Just spray a little fairly weak caustic on the plate. After cleaning, give the plate a remedial cleaning, and then put it in the baggie with the spray, and probably within a couple of days you'll have a good coating on it.
Yeah, keep it warm. That's we found that down in Peru.
Put it out in the sun that's what I did, and I got a really nice coating on some coils, just so even and so beautiful.
Yeah.
Don't assume that she knows anything.
Really?
Go right to the caustic too. Tell her what about the caustic, what kind of caustic she used. Don't assume that she knows anything. Just
we've got a really good source of caustic in Canada at Home Hardware. It's relatively cheap. You can get it in 6 pound tubs for about $23.
Really?
And it's fabulous stuff.
Okay, what is it called? Is it called just regular caustic, or what do they call it?
It's called a pure lye.
Pure lye. Huh. I had no idea.
If you go to Home Hardware website and just type in lye, you'll get this 6-gallon jug of lye crystals, and I've been using that since I started, and it's amazing stuff. It's so clean.
Yeah.
Well, can I come in here? What I notice, I'm trying to get my friends who are aware of this stuff to start making their own ganses. Everybody's afraid of the nano-coating process, and as long term, I mean, it's in her interest to learn how to do that, and everything you're saying is correct, and she needs to get that. But it is an art to nano-coating. But what I was saying, my friend, he was afraid. He was like, I don't want a nano-coat. I got some pure caustic here, no problem. It showed him how easy it was. He is still very hesitant, and then you got to worry, and it takes days. But I gave him, we scraped a pencil. And the first time he made GANs, he used a battery charger, a pencil, and a piece of zinc plate. And I showed you the more than enough GANs. Within the first time, his first attempt, overnight, he woke up and he had that much GANs. So, I mean, a lot of these things are easy, but if you assume she knows nothing, she can get a pencil lead, and even if it leaks some of the black out, it's particles, and you can separate them, and it's really fairly easy in the white. Or, I mean, and then long term, she needs to learn how to nano-coat as well. I keep telling my friend he needs to get some experience nano-coating, but he's been making ganses.
Well, Mario, you can take the risk out of using the caustic if you're going to use just the cold caustic. So you don't go through the process that is shown, that Armin's showing. You just go ahead and you're making the caustic. You're just
sure, but I mean, we were talking about.
Then you got cold caustic. Then with the cold caustic, that's what a person still may be a little skeptic, but because they don't know how to put a glove on. But
yeah, that's right. But it also takes days, and you really need to do it several times to get a good coating, or it will come off. In other words, yes, that's all correct, and she needs to learn those things. But she's, when is it, Friday, going for her thing with a pencil?
You can nano-coat copper, and you can nano-coat copper in 1 day.
Okay, that's fine. Yeah, no, you're right.
But I'm saying, okay, you've got variations of variations of value here. You got a value. Is it? I want to make some CO2 GANs now because I want it now. So what is my simplest? And so I'm not worried about the best of the GANs. I just want GANs.
That'll help her immediately. And then she needs to learn how to get more control in the long run. But if she's going for chemo on Friday, be nice to take a pencil and put it in a bucket tonight, and tomorrow morning start washing the GANs. And at least she has some right now.
Here's your drawback, Mario. You got to know, she's got to know, you got to tell her what kind of tools she's going to need. Not only does she need the pencil, she needs something to charge that pencil and that zinc.
Well, it's just a battery charger.
Yeah, maybe she doesn't. Maybe she doesn't have a battery charger.
Well, but you can go buy a battery charger for a few dollars everywhere.
Right. So,
well, I was just a suggestion for immediate use, not cutting up batteries, not nano-coating, no caustics, not taking a couple of days, not worrying about anything. A simple pencil lead and a piece of zinc and a battery charger and some salt water.
That's a high value information there for somebody, and that would be good to do.
And not scary, you know. He was willing to try it with a pencil and a piece of zinc, you know, where he was not. I said, you know, take some nano-coated copper. He was like, no, he'd rather use the pencil lead for now, you know. But anyway,
and the same thing with the copper. The same thing with the copper. You got to find some copper.
Yeah, that's right. Zinc is harder to find for me. I actually scraped Coca-Cola cans at first. That works.
Well, guys, I've come up with a solution, or I haven't, but there is a solution that has made itself available. That's someone has volunteered, someone called Earth Healing on the live stream has volunteered to contact this person, to drive to the person's place to help her. So I'm going to have them contact me and try to set up this connection and get some proper GANs to this person, because I think that it's difficult when someone is ill and they're, you know, trying to create their GANs and so on and focus on doing that, but it's not working out, and we can try to work, you know, help her through that process, but maybe it's better to have someone hands-on, so to speak, just there at the situation, and to help direct the making of GANs, or to give some GANs that could be beneficial. So,
and you go to this GANs, you look at the zinc, because that's the emotions. She's going to deal with the emotions. You look at the CO2, you look at your chart, and she'll have this chart. You'll send her that chart, and because she's got, there's a lot of emotional situation here. So I only have the zinc GANs with the CO2 GANs. If she makes it without putting a LED between the wires, she's going to get both zinc and she's going to get both CO2 in one batch.
Right. Yeah.
And the fellow that's going over there, he already knows all this. So
I'm assuming so. I would like to find out more information. I'm not sure who it is and so on, but it's nice to see that, you know, we bring up this case and people just volunteer, and it sort of, you know, takes care of itself in a way. This is the new way for the world to operate. We bring up an issue, and there's those out there that know how to deal with it, and bingo, it gets dealt with. And that's so beautiful. I'm so appreciative. Thank you, Earth Healing.
And another thing that's the amino acid that's on the GANs, there's the value there, as it should be emphasized as well. So yeah, I'm done for a while. I'll let someone else talk. I'm gonna bite my tongue.
Breaker. Speaking of CO2 GANs, I went out for sushi a couple of days ago for dinner. When I got home, I got an extreme headache and big pressure behind my left eye and that kind of thing. Well, in my case, a headache is virtually non-existent. I can't remember the last time I ever had one. So I immediately flashed Mr. Keshe's poisoning technique or solution, and I went and pulled off 10 cc's of CO2 gas, or water rather, put it in an 8-ounce glass of purified water and drank it down, and within 10 minutes the headache was gone.
That's a good one.
So I'm thinking maybe I got food poisoning, from or some kind of poisoning from the sushi. So
definitely something. If you know your head that well, then obviously there's something astray, and that's a good testimonial. Maybe you want to write that up at the testimonial site. Appreciate it.
Yeah. Hey, it's Lee here.
Hi, Lee.
I've been having a lot of trouble making the CO2 gans, so this past month or so, I decided to test all kinds of different salt concentrations from 2% up to 28%. I found around 4% was giving me some good production, sort of between 3 and 8%. Above that, I got nothing in the teens. And then when I got into the 24, 28%, I was making CO2 again. So that was interesting. But when I put a diode on it, I get nothing. I can't make pure CO2 gas no matter what I try. I've tried 4 different methods, but anyway.
Which end do you put to positive and which end to negative? Is that have you tried it both ways?
I tried it both ways. I had after I found out where my salt concentration was best, then I put about 4 or 5. Actually, got 5 different pots every 2% around that, and I put the diodes on one way, I got nothing, and then I switched the diodes around the other way, I got nothing. So,
what kind of LEDs are you using?
Just a small little LED that I got from Hong Kong.
Tiny little ones.
I got 100 of them.
I was wondering if that makes a difference in terms of some of them are rated for 12 volts, some of them for 1.5 volts or 2 volts or 3 volts or so.
Should be very small LEDs, they're just
the standard little tiny ones.
Yeah.
Yeah, I'm not sure.
Anyway.
Anybody else have similar results to that? That was interesting about the salt content, how there was a in-between salt content that didn't produce the GANs for you.
Yeah, I was surprised there.
Has anyone heard of that before? Any feedback on that item? That's quite unusual. It's I know that the more salt from my experience, like if the water levels go down or your salt concentration, you put more salt water in or whatever, then it produces GANs faster, but it also puts salt all over your gear and ends up taking off the nano-coating takes the copper oxide off the copper pretty good. So yeah, interesting.
I have a tip of the day.
Okay.
You wanna check it out? Turn on the camera.
Okay, just a sec. Let me get you on my live stream. Okay, go ahead.
As you know, we've discussed in the past, I've made a lot of different kinds of ganses, and of course I had to do it the hardest way, which is ordinary. When I would make my gans, I would use a bubbler. Denny mentioned that before, and rinsing the gans is kind of an issue with me in that it takes so long and the quantity of water. Well, we've talked about the water, that's already been covered on other programs by me. But what I found out was in the process of rinsing my gans, I make all my gans in one of these gizmos. And when I do my rinsing, I take my bubbler motor and set it on top. And the gans sells out in about 1/10 of the time that it would take it normally with gravity and whatnot to settle. So that might help somebody with their washing their gans. Over.
So you attribute that to the vibration factor that helps it settle out, or?
Precisely.
Yeah, I think that's right. I was wondering if like an ultrasonic device would work that way too, and just basically makes everything vibrate a little more and settles out the.
Yeah, sure.
Makes
Sure
the
would.
lighter from the heavier separate faster. I guess anything. I was also thinking if what if we went from water to alcohol and dried the gans essentially in alcohol from the water, and would it settle out in a different way in alcohol? That's a process I'd like to try, because apparently with some types of nanomaterials, what they do is they take it out of the water condition and turn it into the alcohol condition, and then they go from alcohol to, is it another kind of alcohol, or perhaps to it's a three-part process. You start with water and you end up going into alcohol essentially, but there's three parts to it altogether. So I'm wondering if that's a way, and you can dry your nanomaterials without the oxidation factor going into it from the water and so on. The idea being to have pure, say you wanted pure copper oxide black powder nanomaterial, then it may require a process like that to get rid of the water, which might act as a oxidizer or something that would contaminate the sample once you got your initial materials. So you can preserve it. And I thought maybe that's a way to preserve the gans so that it could be dried in order to be reconstituted in water later, which is the only proper way to mail and have this stuff going worldwide and so on, is be as a powder rather than a liquid. Liquids the shipping companies don't like to ship, so I think that's going to be, or is, the way that the GANS is going for Keshe Foundation, I think. You know anything about that, John, or somebody else?
I've dried GANs. I don't know about doing it with alcohol. It's an interesting idea. I'd like to try it. But when I dried my GANs, I was never able to get it to rehydrate. It simply would not.
Yeah, that's the issue. So I'm wondering if we go through the process with the alcohol first, then maybe it'll keep it from clumping, let's say, when it's reconstituted.
Maybe.
I remember you saying that, John, before, that you could never get your dried GANs. I tried it too. I couldn't. But Mr. Keshe said either last week or a couple of weeks ago, it's a very simple process to turn it back into a liquid again. He didn't say how. I thought maybe you had already figured that out or something. So, yeah, Mr. Keshe said there's a very simple process to turn it back into.
That's right. He mentioned some kind of process. So I'm wondering if it might be this. It's sort of a standard lab technique or whatever that you use with certain materials, is to basically flush it with. What was it? It wasn't alcohol to start with. It was some other thing.
Ethanol.
It might have been methanol. Yeah, methyl alcohol will tend to combine with the water, and then you use ethanol to dry the methanol or something like that. Anyway.
But don't you get the fields of the alcohol into your CO2 GANs or whatever you're making? Doesn't that taint?
I don't think it interacts with the alcohols, the way I understand it. At least for the materials they were working with, it may be different with our GANS materials. It may not work with the alcohol at all. I'm not sure.
Well, I think the matter state alcohol, the fields are going to be so small it won't make a difference. When you're dealing with something like fruit, there's a large component of GANs within that fruit, so it's going to have a large field. But a bottle of isopropanol, I don't think there's going to be a significant field, plasma field that existing.
What you'd want to do when you're dealing with your alcohol is you make some dilute solutions. You don't use your 98% alcohol. You dilute it down and do your testing from a light dilution.
Well, some of the alcohols, like Rick was mentioning, some of the alcohols are not water soluble, so there's really no way to dilute them. Isopropanol is highly water soluble, so that may be something that Mr. Keshe is bringing up. Is you take your dried gans, you mix it with a little bit of iso, and then you mix it with the water. I don't know. I'd have to try it. I'd have to dry some gans and test it, because I do have some isopropanol here.
I wonder if the gans would settle up faster by just putting a bit of iso into it as well, into the water solution.
Well, specific gravity of isopropanol, I think, is less than water, so it probably would settle faster.
Mm-hmm.
A friend of mine has suggested using these inert spitballs, the very thing that is put into a disposable diaper that absorbs the water. You use the spitball to absorb the liquid plasma, and then let it evaporate, and the liquid plasma is still going to be on that spitball, so you can take the it's just an inert type of I don't know if it's plastic or not, but it is of some sort. Does anybody
maybe it's
know
zeolite
about this stuff? And does anybody know about that stuff?
Is it zeolite? Is that what you mean? Little they're hollow, or sort of very light hollow balls.
Zeolite. They're used in gardening as well. If you want to extend you're going to go leave your place for a while, and you don't want to water your plants.
Yeah.
You put these crystals in the water. I mean, in the soil, and it holds a lot more water, and then it releases the water.
Right.
So that your plants don't die while you're gone.
Yeah, it's moisture absorbent. Forget what it's called now.
Well, if you. That's Christopher. He needs my help. So, but you can look on Google under spitball, and
well, that's what they're actually calling. Okay, I wonder if you're just making that up.
No, that's you can Google spitball, and you can get a lot of information from that. I'm going to go help Christopher out.
I hope there's not information on the spitball fight we had in grade 8. I might get detention. Yeah, they probably have pictures of right there in the classroom by now. Here's your history, here's your past, right in front of your face. You didn't know that we have cameras that can go into the past. Okay, well, Gordon has a... Go ahead.
Rick, I'd like to go back to nano-coating from last week's show.
Okay.
I forgot who brought it up, but they're talking about nano-coating, say, a spool of copper wire with the insulation left on it.
Right.
I had an idea, and I'm an idea guy. I'm not actually a hands-on guy, so bear with me here. I'm trying to understand the nano-coating process. And what if we were to take some of that wire that had the coating on it, the insulation, and we wound it into a coil that we use in magrav, both large coil and small coil, left hand and right hand, formed it into the circle, and then stuck one end of it into a caustic bath and let it nano-coat. Now, where I'm going here with this is my understanding of the GANs is a visual representation of a field for us common humans to understand what GANs is, or what a field is. Now, what I'm thinking, carrying this on just a tad farther, is what if we did our capacitors as well at the same time, and nano-coat them the same way. You could probably do it held pins as well. And then we built our magrav. Before we did that, of course, we dragged the coils through our GANs soup tried it out, assembled the magrav. I wonder if that would work.
You're saying excuse me, you're saying the gans would be on top of the insulation of the wire?
10-4.
I see. Well, that makes a big gap. Let's do a screen share.
Here's my thought process. I'm thinking that the gas is in fact a placeholder for the field. Okay, the reason we put it on there is to hold the field in place, as opposed to using gas water. So if that's logical, and it was on top of the insulation, the field would still be there.
Yes, but
gas would be touching a portion of the exposed wire that we use during the gas coating process. So it's just an idea. I don't know if I'm in left field or right field what, but it might eliminate a lot of the scratching and nicking and what goes on with these cold while we're assembling the magrav. Just an idea.
Okay.
I see one problem about that is you still have to nano-coat that. The plastic has to be nano-coated as well. And it will get nano-coated, but I've had a lot of experience nano-coating plastic. And if the plastic has to be nano-coated enough to not burn, and you got a fairly thick plastic there, it'll get nano-coated on the outside and the inside, okay, but you got a lot of it could be a problem if you don't get the plastic itself nano-coated completely, especially if you're using it for a magrav unit. I mean, you guys are tech guys, so I don't know, can you make it? Do you worry about the plastic melting and burning?
Oh, yes.
Yeah, see, so that could be a bit of a problem. If you get the plastic nano-coated thoroughly, then what you got is a CH bond there. So you got hydrogen, so that's okay. In fact, that's probably better if you can do it that way. But, if you don't get that plastic nano-coated enough, you're going to have a fire on your hands, right?
Well, if something goes wrong, if you look on my YouTube channel, the latest one, I think I've got it's posted in the Keshe Peru room. I'll put it up on Facebook too. But we did a test in Peru today of a new magrav that Dave was in a rush to assemble, and he didn't assemble it right. And there was a horrendous flash when they plugged it in. Something like that, yeah, you're probably going to have some issues with smoke and fire. And, if it's working perfectly, chances are it's not even going to get warm. But if something goes wrong, you're asking for it.
What I was thinking was if we look at the wire, say the wire's inside here, and this is the red is the red part here is the insulation around the wire, right? Then the wire is going to have its nano-coating, which would be the black part, around the wire on the outside part of the wire, but inside the insulation. But the fields of this wire, the fields of the nano-coated wire, may only extend out a certain length. And that may not be that they extend out in the field strength that you want, the width of that insulation, I'm thinking. I don't think these fields are like out here. I think they're going to be in close to the wire. And I think it needs that gans. If the gans is the blue, this blue, whoops, blue, not eraser, draw, blue, no, not eraser, blue, thank you. Okay, so we got this blue gans on the outside of the insulation all over here. There's to me it'd be too much of a gap or a distance between that insulation. It's plastic all in between there, where it should be more of an interaction. fact, some of the GANs now we understand is actually, it's like it's impregnated or growing right into the nano-coating. Doesn't come off so easily. It's actually, you know, embedded into it. So it becomes almost one with that nano-coating in order for the fields to interact between the nano and the GANs, I believe. I don't think
also,
it will work.
if I could offer a slightly different perspective, Don, the way that a number of us are viewing the nanomaterials, the nano-coating that we're putting on the wire, is a conduit and a trap for the plasma. It's a condition where the plasmatic energy, these interacting magnetic and gravitational fields, want to collect. The GANs that we put on there is the source of that plasmatic energy. So like Rick was saying, if you have them too far apart, you're just not going to get the interaction, and it's not going to absorb into that the nanomaterials in a sufficient manner to create the effects we want.
Right. Like the way I understand it. Go ahead. Sorry.
Okay, I can see that. It was just it was kind of a brainstorm.
Well,
in that, you know, we talk so much about the fields and how you can't lifting, meaning substance doesn't really limit a field, and that's what made me think, well, maybe this insulation wouldn't. I could see where it would limit the field if you nano-coated that plastic, because then you've got a barrier from the wire to the top side of that plastic. So, you know, I'm not.
The field, you know, about a jar of GANs is going to have a field that's miles in diameter. Now, whether or not that field conforms to what we understand as the inverse square law, I don't know. If it does, then a millimeter really will matter.
Okay.
And the other factor is the actual nanomaterial. If we look at, say this is the, up here is the element copper, just plain copper. Well, it's got a field, but it's, the atoms are very tight together, and the field is mostly just in the metal itself. It doesn't exude fields around the metal. And then we go into the copper oxide. Then we have a greater radius of the fields, because the copper oxide is more liberated. Instead of being all tight together, it's got a gap, it's got spaces that allow for more plasmatic flow. And then if we go one step further to the GANs material, same size particle, but the fields could be, like John was saying, much greater than the nano, and which is much greater than the original element or physicality. So as we each gradation has more degrees of freedom. The GANs might have a spacing more like this compared to the nano beside it. Or sorry, the nano there, and the copper itself over here, which will have a very tight spacing down there actually.
Hey Rick, can I show you a picture of the nano-coated wires on my car magrav?
Please do. I'm going to clear this, and we'll get out of here. Okay, you want to start your video, you mean, or you have you want to do screen share?
I just want to show some
Okay.
pictures. I'm going to share my screen here, if I can find the right. Okay, so this is that car magrav I was showing you last week. I had caustic soda inside the pipes here to nano-coat all the plastic chips that were in the pipe, and it's sitting out here baking in the sun. But this, yeah, I made two of these. One of them had about 30-inch long wires on it, and one had about 4-foot long wires on it. And before I put it in the car, what I wanted to do was I wanted to nano-coat these wires. So I decided I was going to strip the ends down a bit and stick the ends in some caustic soda. But that's the other unit. But when I stripped the ends down, the 2-foot long wires, they're in a really dark black, nice and black. All the wires are black. And that's where because when I assembled this thing originally, I twisted the wires together. And in 3 days, these 2-foot wires turned black. This is the 4-foot wire up above here, and it's just starting to turn gray. 2 days later, after 5 days, it was nice and black. So,
sorry, could you help me with it? Did you dip these in the caustic, or?
No, I didn't.
This was before you even got to dip them.
Plasma energy from the car unit.
Wow.
So I'm just getting energy out of these coils. So, so I was surprised. I've never seen the wires, nano-coat so fast.
Yeah, it's amazing, isn't it?
So, and since how these are two separate coils, they're not connected, and they're putting out plasma energy for sure.
Yeah, stranded wire coats really quickly. The solid core wire takes a lot longer.
So,
interesting. Thanks for showing that. It's a nice picture. So you've hooked up 2 magrav units in the infinity loop here. Or what are you hooking up? Or this is just the coils on your car unit that you've hooked together?
This is the coils on the car unit patterned after what the guys in Peru are doing.
Right, so you do a infinity loop between the 2 sets of coils, basically.
The 2 coils are not connected together, Rick.
Oh, that's right. Yeah, we talked about this last week.
I was gonna demo and show how to hook it up and how to make it and everything here. I've got all set up for that.
Great.
Make sure I'm on the right camera. And this is just a demo unit. This is not nano-coated yet. It's a typical magrav, same thing you'd find in your house unit. Double coils. Magnetic and
hold on, wait a minute, John. Just gotta get you pinned on a second. Okay, go ahead. Sorry.
Okay. Identical coils to a home magrav, to what we're already making. Everybody knows how to make these. There's a small coil inside of this coil. There's a little small coil inside of this coil. The connections are all the same. This one is this design. The way I've got this connected is so that you can do a complete assembly and then nano-coat it. So you're not messing with your nano-coating afterwards. We've got some better versions of these connections out now that are going to be released shortly that work better. But you make 2 of these, and they're essentially independent in your system. You noticed with the picture with Lee's system, he just used like PVC pipe caps. Those work really good. And you make your coils, you nano-coat them, you gans-coat them, and you also have your little bottle of gans in the center. You secure that on each, one on each cap, so you have 2 caps. On the side that attaches to the negative, to the battery, you connect your gravitational lead, which would normally be the input of the coil, or I think they're referring to it as the negative on the blueprints. I don't like positive and negative. It's too confusing. This is the gravitational. This is the one that goes to the start of the center inside coil.
And you say it connects to the battery. What part of the battery?
This goes to the negative of the battery.
Okay, thank you.
Okay. The gravitational of that same coil, you don't do anything with. You just tuck it away so that it's not attached to anything. And you do the exact opposite for the other coil. The gravitational would just Lee's got them wound around in the center, like in a loop, and that's probably a really good idea. I'd like to see Dave try that too. But the magnetical would go to the positive of the battery. These coils are not connected together. They're in proximity because they're side by side within those two caps. But there's no connection between them. So there's no possible chance of a short circuit on your battery. And we are getting amazing results from these things. One lady, I was hoping she'd come in tonight, but I think she got tired and went to bed. She actually went to Peru. She built one in Peru, took it home, put it on her 300D Mercedes, mid-80s Mercedes, which was getting about 26 miles to the gallon, diesel, standard transmission. She's been driving it for a while, knows the car pretty well. Put the system on, and today she reported she drove 76.3 miles, and she got 51.75 miles to the gallon. And some of that driving was at 90 miles an hour. So if she was to keep it down, 50, 60 miles an hour, she'd probably be up in 65, 70 miles per gallon. But we're going to be, we've got her constantly recording so we can see if it grows, if it builds, if there's any adjustments, if there's any fluctuations in this. We've also got several of these units on taxis and commercial vehicles down in Peru, and they're averaging about 35% increase in mileage just within the first 15 days. So this works really good. I'm very impressed with this system, and it's so simple to make.
Right on. How close would those coils be once they're assembled in the unit, the two separate coil units? Like,
there'd be about, I would think, 1.5 inches, maybe 1.75 inches between them.
About the same distance as in the magrav unit?
Pretty close, yeah. Pretty close.
Okay.
With Dave's units, he's not using a little short cup like this. He's got a fairly tall little bottle like that. And his bottles are basically touching. And he's going to try a system where he's using just one bottle between the two to see if that's going to work as well. He tried that with a plastic tube over it so he could stabilize this, because the roads in Peru are horrible and the systems are falling apart. We can't make them tough enough. But that one didn't work at all. It was probably because the plastic tubing that he had wrapped around here was actually dissipating all of the plasma fields that his GANS bottles were making. But the GANS is the same as the home unit. It's a mix of CO2, CH3, and copper oxide. He's using the same GANS that he's using in his home units, and he's getting really good results. I'm very, very happy with the way work is going down there.
That's great news. Great news.
You're going to wind up, if you put that on your car, I'm going to stick my neck out and say you're going to get at least 30%. You're probably going to double your mileage.
That's amazing. If this can be documented and made into a test, say a government test or something like that, they would freak out if they would get some kind of results like that. There's so many different additives and different devices that have been tried on vehicles, and most of them will get maybe a 2 or 3% difference. Some of the really good devices and products might give a 10% difference in mileage or power depending, but nothing like the simplicity and the low cost and performance or apparently the major improvements of this unit. So interesting.
Well, we can see from Lee's demonstration with his photographs that these systems, even though they are, like you say, really simplistic, very, very basic systems, the plasma flow is phenomenal. We're having trouble with the magrav systems. We're having trouble getting 4 feet of nano-coated wire in 3 months, whereas he's getting almost 5 feet of nano-coated wire in a couple of days, and with no other input. It's totally passive. Yet it creates this massive dynamic plasma field, which I think is because of the two systems, because they're not going to be identical. So you're going to have a gradient between the two systems, and that is where you're generating that plasma flow, and it seems to be a very effective way to produce that plasma flow.
Good one. Well, we do seem to be told and realize that the greater the gradient or the demand on the system, the more it will tend to perform. So maybe that gap between them makes the plasma want to jump the gap, you might say, or that, you know, jumping of the gap is good exercise for the plasma. You know, jump, plasma, jump, and the way it goes. We have a question from Francie in the chat. So also the wires in the house, when you have a magrav installed, will be nano-coated? And yes, this has been one of the premises of the magrav unit from day one, pretty much, that Mr. Keshe was elucidating about how the nano-coating will affect the wires in the house. And it may not be that all the wires in the house will turn black as well, but because if it's a few atomic layers, then you won't be able to even see the nano-coating. So it could be nano-coated without being black necessarily. Some of them may turn black, in which case that's the way it goes, and it turns the whole house into a plasmatic chamber or a plasmatic generator, you might say, and should make the magrav unit work better, and perhaps eventually make it so you don't even need to use the magrav unit in order to get free or near free energy. Is that about the way it works, John, you'd say?
That's pretty much the way we're seeing things move. And once we can find that precise imbalance that we're looking for, because we're not looking for the balance. A balance, we're going to create a stable, non-moving system. It's like matter is balanced plasma. We're looking for that very specific imbalance, which is creating the flow that we're looking for, that we can adjust to create whatever we want.
Yeah, good point.
Can I ask a question, please?
Yes, certainly.
Yes.
Is that Francie?
Yes, that's me.
Hi.
Good morning. Good evening. The first time that I was in your live stream, I think it was Armin who told me to put a coil, like the magrav coil, to my battery from the meadow. And then he said connected infinity. Do you remember? Are you there?
Yeah.
Yep.
Yep. We're all here. Okay, so Armin said to create the spiral coils and then connect them with the infinity loop. Is that what you're saying?
Yes, and then the infinity loop. And I'm talking about plus and minus, excuse me. Do I put the black one from the black one to the red one of the battery, or do I or normal black to black and red to red?
Okay, so the black from which exactly?
The black from the coil. When I look to this infinity drawing.
Okay, let's bring up the drawing somewhere. Let me see, what do we got for that?
This is the one with two magravs hooked up, one backwards.
No, it is the lambda scout. Then he said you connect the battery with your coil in the infinity loop. Then I thought I have to make this lambda scout out of it, but then my battery is not giving any voltage. So I turn and I put the red on the red one and the black on the black one. Is that also infinity, or is that something else?
I'm trying to picture it. I can't wrap my mind around it. I think it's something else. and the killing the batteries and causing electrical issues. This is why we developed this two-coil non-connected system, so that it won't. There's no way it's going to kill your battery because there's no electrical connection between the two poles. It's entirely plasmatic.
Right, yeah, you might run, are you connecting, you mean you're connecting the two, you have a spiral on each post, and you're connecting them together somehow? Is that what you mean?
Well, I made John showed us this coil some minutes before. I have also a coil like that, and one wire is the red one, and one wire is the black one. So I thought when I do infinity, I put the red one on the black of the battery, and the black one on the red from the battery. But then it is giving no electricity. So I put the red one on the red one from the battery, and the black one to the black one of the battery. And then I have 6 volts in my battery. I put also GaNs in the middle. I put GaNs a ball with CO2 GaNs in the middle. The ping pong ball.
Yeah.
Well, I'm not sure. I think we'd have to see maybe a picture of your setup or something to understand more about it. What were you going to say, John?
Oh, yeah, I'm not able to visualize what you're describing as far as the device itself. When you describe, put the red on the black and the black on the red, yeah, okay, I can see that. But what's between them? What are the wires connected to? What's the circuit that is on the other end of those wires? That's where I'm not clear.
The battery and the solar panel.
Okay, so you're talking about the red and the black from the solar panel and the battery, and you're trying to connect them backwards. Backwards to the battery? Maybe we have to do a drawing or something here to see, perhaps. I can do
with the solar panel connection, your red lead should go to positive, your black lead should go to negative on your battery.
I did.
Okay. If you hook them up backwards, you're basically reverse biasing your battery, and yeah, it's not going to charge.
Yeah, it could actually discharge in that case, because it could discharge through the solar panel, perhaps.
Well, you're going to be pumping, the battery's trying to put electrons out the negative side, and you're pumping electrons out or back into the negative side. And yeah, it's it's not going to work. So in that case, yeah, you want it. It's like a jumper cable on a car. When you go and jump a car, you don't hook them up in series. You hook them up in parallel. So black to black, red to red. Keep it that way.
What would be a way? What might be a way of creating an infinity loop with that basic battery and solar panel arrangement? I wonder.
The car system that we just described. If you mount one of those on your batteries, you're going to get an amazing effect out of it. We've got a fellow in Peru right now who is doing a test with a solar system, and initial reports are showing really good results.
Okay, well that might be a solution, is to try to make one of the double coil automotive type arrangements and hook that up to the solar everlasting battery in your field.
Yeah.
Does that make sense? Okay.
And something else that we've noticed, just doing some testing, it's in the video. I posted the video in the chat, the YouTube for that. And Dave was given a couple of dead, motorcycle batteries. One had, when he measured it, was 3.4 volts, something silly like that. He took the car magrav unit, attached it to this dead battery, nothing else, no other input or anything, and in a few hours he was able to measure 19 volts on this battery.
19 volts.
We're not, we've discussed this at length. I'm not there, so I can't really say for certain, but I'm quite sure that it's not actually charging the battery. It's more using the battery as a capacitor.
Sort of a surface charge or something.
Yeah, because if he puts a diode across it, on a 6-volt battery, he can put a regular like 1.2 volt diode right across the battery terminals, and it just lights the diode up. It's very happy. So he doesn't have the current, so he's not charging the battery itself. But what's really interesting is he gets this massive effect when he hooks this magrav to it.
Yeah.
Now, which tells us there is definitely something going on there.
Yeah, well, we'll have to wait for more results. That sounds really interesting.
And from what we saw from Lee's demonstration, just hooking the two ends together, making a loop, so you have this plasmatic gap between the two coils with your GaNs source, plasma source, and it nano-coats that big 5-foot-long loop of wire in 3 days. That's pretty powerful.
Mm-hmm.
So we're definitely onto something, and this is, I'm going to push to get this pursued by as many people as possible, because I think we've got some very interesting possibilities with this as far as the plasma source goes.
So there's a question from Gordon in the chat. What if you wanted to nano-coat something like your car? How do you prep the surface for coating? Would you tent the whole car with clear plastic? And he says, just spitballing for fun.
Yeah. Well, I sent him a reply, and it says your car's going to get coated all by itself just by having the plasma flowing in it.
Right, and we've talked about some things like
paint off and spray it with caustic.
Right, we've talked about some things about like maybe it's better to put the wire onto the motor block itself rather than the battery, and to stick a wire in the intake manifold and things like this. What about that kind of alteration in order to help the nano-coating process of the car, or create the fields at least?
Well, with Jackie's Mercedes, she had the system, she had the double coil system on her battery at first and got really nice results and was very happy with it. And she's saying, well, is this it? Is there more? Is this the best way? And I suggested try to put the ground side, the negative, the gravitational side, onto your intake manifold of your diesel, because there's really no electrical part in a diesel engine. You know, other than the starter and a couple of sensors, that's essentially it. She wasn't able to do directly to the intake manifold. She could only get it to the fuel pump. And when she did that, she did a short test, 60, 70 miles, and she was getting just a little bit more than she was normally without the system on there. So she removed it, put it back on her battery, and her mileage went through the roof. So I think on the battery, we need that trigger from the battery to get the plasma to move. But once you create this field, because of the gap between the two coils, you're actually creating a field that's going to be permeating the engine anyway. So we may not have to direct it at all.
Okay.
You're still muted. There you go.
Theodore says in the live stream chat, Rick, would you be willing to share that I believe there's evidence to suggest it's possible to nano-coat wire using the gans-making process with the group? The gans-making process to nano.
Possible, maybe. You would need a source of dynamic plasma. That's the thing. If you want to nano-coat a long strip of wire, you have to introduce a dynamic plasma flow through that wire. The gans-making process, having a nano plate and a zinc plate in salt water, is not really creating a dynamic plasma source. And if it is, it's very, very minor, because I've had little short 6-inch long pieces of wire between my two plates, and they never got nano-coated.
Okay, that's a good point. Okay.
if I could add to that, I got the exact opposite. I did have a short piece of wire from my nano-coated plate to the zinc plate, and the whole thing nano-coated.
But you were using electricity, weren't you, a bit there?
No, I was not.
Oh, okay.
I was not, and that was the amazing thing. I had a single piece of wire. You know, it was not done the way that the very first generation of GANs kits was done, where you had two pieces of wire and you twist them up. No, what I did was I took a single piece of wire and I connected the nano plate with the zinc plate, and it nano coated. When I cut the wire in the center and I stripped it to attach a battery, the wire was nano coated through and through.
Okay, cool.
And right now, I'm actually using electricity, but I'm using electricity to drive plasma. So what I have is I have my DC power supply hooked up to a 3-stacker coil set. And the output of the 3-stacker then goes to you know, the positive, which is the other metals in the GANs kit, and the negative, which is already plasmatic by virtue of the nano-coated plates, then, you know, goes back to the DC power supply. So effectively what I have going on in my GANs kits right now are completely plasmatic flow, and the wires are getting nano-coated.
Very interesting.
Interesting. Well, you mentioned earlier, John, about different environments and so on, and how some people require more salt and less salt and so on. And that seems to be the case here. It's a different environment somehow, or some different materials involved. Like maybe the copper wires different. For example, the certain wires will tend to nano-coat and certain ones won't so easily. So maybe there's a difference between what's being used there and so on. So,
well, I think the nature and the value of the inherent ambient plasma field is going to vary from, you know, 10 feet away. How much of a difference that's going to make, I don't know yet. Go ahead.
John, sorry. Did you use an insulated wire between the nano-coated plate and the zinc plate?
No, that's probably why.
That's probably why, because I used insulated stranded wire and the whole thing nano-coated. And Mr. Keshe alluded to this, that the insulation is key because the nano-coating grows against the insulation. But when there's no pressure, the nano-coating takes far, far longer to happen.
Okay. Yeah, the nano-coating I did for my triangle plasma, the wireless reactor, they're just stuck in a pop bottle with caustic soda in the pop bottle. They nano-coated in like 4 days. You can watch it grow. It was amazing. So yeah, I mean, we're just learning. We're just starting to touch this technology, and there's so much we don't know yet about this. All the little variables, all the little things, you know, we know a little bit. We know that solid core wire doesn't nano-coat as easily as a multi-strand wire. We know that a non-insulated wire, if it's exposed to atmosphere, it's not going to nano-coat hardly at all. You know, if it does, it's going to take forever. But the little fine details where we can fine-tune these systems to work everywhere equally, we're just not there yet. So that's a lot of the reason why we're having so much variability in the results. Some people get it to work really well. Some people it just never works at all. And it's probably going to be something really simple, like they need an extra turn on their coil, or their coil needs to be another 1/16 of an inch larger, or it's going to be something really simple that we just haven't discovered yet. With the more people we have experimenting and the more data we collect, the faster we're going to get there. Rick is still typing in.
Yeah, I've got Theodore says he sent me a video, and I'm trying to find out. He said sent it to me on cell phone, but that doesn't tell me very much about what where to get the video. I'm not sure what he means by cell phone. So anyways, there's some video out there that I might be able to show. Okay, so what else? What else?
Well, I have something that I'm not sure what to make of this. Okay, somebody, I don't know, a few months ago mentioned that they put magnets underneath their CH3 containers and it helps settle the CH3 much faster. So I tried that and it seemed to work really, really well. And I found I think I showed you before, it's easier with the plastic than it is with the thicker glass. But you can push the CH3 around with the magnet. I used it to sat around condensing it on the sides of the walls and then shake it down. And, you know, it worked really well. And I was thinking, what if I had a very little bit of CH3? I kept having some problems. I just had a little bit of CH3. So I started harvesting some other CH3. And I thought, I wonder what would happen if I put some magnets over the container when I started harvesting the CH3. Can I get magnetized CH3 that would actually not just be acting like a magnetic material, but actually act like a magnet? So I did that. I put magnets underneath the container, wasn't washing it and all, and I didn't seem to have, I couldn't see any difference. So what I did was I ended up mixing the new batch of CH3 I'd had with my old batch of CH3. And I'll show you my camera here. Let's see. This has been sitting. I had magnets underneath it. I took the magnets off. I've got another container. I got the magnets sitting on top. It will not settle. I pour it off and it will not settle. Some of it settled about as much as my original, but I think I don't know what to think. It will not settle. It's staying like that. And it was clear water on top. I poured that water off. The other one had clear water on top. When I mixed the two different batches of GANs, I don't know. I think I have some sort of polarity, or anybody have any thoughts on that? Why it's staying separated? I think I might have magnetized GANs, but I got it mixed up with the not magnetized GANs, and I've been
You've got GANs in there from two different batches, right?
Yeah.
Okay, so you're going to have two different strengths of GANs because they're not always going to be the same.
Well, yeah, but I've done that before. Made several different batches and mixed them together. I never had it where the water simply will not settle. That's three. So they're just sitting there. Some of it settled on the bottom, but the rest of it just simply is not. So I don't know. Yeah, I don't know what to make of it.
There could be a magnetic anomaly going on there. I can't say one way or the other, but I do know that individual batches of GANs, you're going to get different strengths in your materials. And if you have a sufficient difference in that strength, then it will stratify.
Yeah. It's hard it's not stratifying though. Not really.
Well, yeah, kind of it is. You've got heavy stuff on the bottom and you get the light stuff on top.
Yeah, but even the other stuff I poured off of that. Okay, I'll show you. Now this one I put a magnet underneath it. You see there's some collecting on the bottom, but that's been 2 or 3 days.
Mm-hmm. Yes. Yeah, my CH3, the water never goes totally clear. It's always got a little bit of an orange tinge to it.
Well, okay.
This bottle here, that has been just sitting, oops, wrong camera. That one has just been sitting for, close to 3 weeks, hasn't been touched. and it's still got that orange tinge to it.
Okay. Really, huh? Okay.
I beg to differ, you guys. Mine stays clear.
Yeah, I always had mine staying clear. I've always had mine staying clear. This is the first time I can't get any Gans water to drink. I'm making some more, and it's settling. Okay, here's... let me show you my camera here. This I made yesterday. Oh, wait. Why is my camera? Okay. I made this yesterday. This is the first washing. And it's clearer than that. And it's much clearer than that. So I'm just not sure. Just not sure what's going on with that.
Well, all I could suggest, Mario, is try to replicate it.
There's a possibility, Mario, that you've got iron particles in your GANs and that they are magnetized.
Yes, I would say that's probably true. The iron will tend to form rust, and that'll stain the water, and it'll stain your cup and everything else probably. And it won't come out of the water like the GANs will. And I found with my CH3, when I used a magnet on the side of the container, I could actually pull up some particles from the bottom up to the sides of the container. But when I looked really closely at those particles, they were mostly sort of rust particles, or they had more of the physicality iron involved with them rather than the GANs itself.
Okay.
And there's even some black particles in there from the black iron oxide.
How about trying to rinse it with a magnet connected to the container?
Yeah, that's a good idea.
Do that. Yeah, I pretty much always do that. But the funny thing is, well, I just don't know what to make.
Like, would you want to, on that last comment, would you want to be saving the magnetic stuff or throwing away the magnetic stuff that's stuck to the magnet?
Yeah, that's a good question. That's
like, do other people, are other people finding the CH3 magnetic? Is there some results that way? Can anyone attest to it actually being attracted to a magnet, or is it the when it's not pure CH3, then it's attracted to a magnet?
Well, it can't. It's got to be interacting with the CH3 as far as I can tell, because normally I have magnets underneath the containers, like this one. This shut my camera off again. This one. Oh. Okay.
No, this one.
There we go.
That one.
All right. This has still got salt water in it, but the magnets pulled all of this GANs down to the bottom. I can see possibly there's some magnetic metal particles in there, but that's pretty much GANs, mostly. And it got all pulled down there right away. Normally without the magnets under there.
Do you have a neodymium magnet handy that you can just put it on there and just see if it pulls it up the side of the container when you try to, move it along the side there?
It will. It'll do that on all of these.
Sometimes it's a little tricky to get it to go. You might have to...
But you see it coming up there. This is a really, really weak, kid's toy magnet. It's not very strong, but if I put this there... There's also salt water in here still, too. But you see it's coming up on the side there.
Okay, you can't really see from here, but...
No, but it definitely will react. It'll take a few minutes for it to...
Try moving it around the bottom, like all around the bottom, and pull like the material to...
Yeah, there you go. Wow, it's not seeming to be reacting the way it was.
Go underneath the container.
Yeah, that's what I was thinking. Go underneath and see if you can pull some of the material around there.
No, it's not really doing it the same way. See, I had it pushing around and pulling around on the other one a lot, but it's not seeming to. Wow, okay, it's weird.
So about 1.5 years ago, when I was making CH3 GANs, that was the test I made. I have a question of my first CH3 GAN. Am I creating rust water, or am I creating CH3 GANs? Because, you know, I'm a novice back then. So the very first thing I did is I grabbed a strong neodymium magnet to see if there was any movement. And luckily for me, there was no movement. So I said, well, I've done a pretty good process here then. Now I got to test my extremes and see if I can get rusty water, and because that's part of the process for me, is I like to test the extremes.
Well, you see, I had this magnet directly under the center, and it wasn't until I shook it up that the GANs actually settle around the bottom here. It was really piled up right where the magnet was. So I know that there's a magnetic effect happening here, but don't seem to be able to. Okay, I'm just not sure what's going on here.
Yes, I would think if I was to want to make rusty water, I would just put iron in the water without the nano-coated copper, and to see what because that's part of the extremes I want to test. I want to see if I'm making CH3 GANs or if I'm making rusty water.
Denny, I think you're probably on the right track in that when I made mine, I just put one of the neodymium batteries or magnets next to the jar, and it's just sucking all the rust particles over to it. You know, we might want to make our CH3 putting the piece of steel in a plastic bag so that you won't pick up the rust fibers dropping into the mix. Maybe that's the way to get around that. Over.
Wow, this does not seem to be. So maybe then all these ganses I have rust particles in there, and that's why they're acting magnets. But this one seems to react to the magnet.
You probably got some CH3, and you look at the ones, yeah, you probably got some CH3 in there, and take a look at your samples, and if it's got the water stays clear on the top, you get the plasma water, and your CH3 stays to the bottom. Yeah, you've done a situation here that yet is not determinable. I can't determine it by just looking at it, and so I can't really give you a true answer.
Yeah, Mario, just set your test CH3 up on a shelf, put the magnet right beside it, and just leave it overnight.
Yeah.
Let it migrate slowly.
Yeah. Well, it pulled some down here. So, but then that looks like GANs to me on the bottom. So I'm not sure what to make of that. It'd be very nice if I actually had magnetized CH3, wouldn't it? Because then I could get the balls to push each other around and act like magnets filling them.
Yes, and it would be great if it was a paramagnetic CH3 where everything would repel from it.
Yeah, that's what I mean. Yeah, it's create motion, sort of cheating in a way, but you know, I mean,
what's cheating when you're looking for a final result? You're looking for a prostate that creates the final result that you want.
That's right. That's right. And it seems to me if I can transfer a field of banana, why can't I transfer the field of a magnet? But then again, you know, I don't know. But I definitely, you know, doing this with the magnets and then mixing that. Because again, this container had about that much GANs in it, and I would fill it with water, and a couple of days, 2 or 3 days later, it's pretty much pure water I could pull off to drink it, whatever. I'd fill it back up, and a few days later it would settle. When I mixed it, it just, you know, didn't settle, wouldn't settle. And the other one, when I mixed it, had completely settled, and I had about twice as much GANs. Now it seems like this GANS is separating from that. I'm wondering if that's a magnetic reaction there or repelling or something. And it didn't seem to settle this. I had magnets underneath it, and it did not settle. When I took the magnets away, this much ended up, after a period of, I don't know, a week, settled down to there, and the rest of it didn't. I poured it off into this, and I put a magnet underneath it, and I got a little bit of that there, but that is whatever is in there. I'm wondering if I'm getting, this is pulling some of the original GANS. I mean, this is, I don't know, thinking I've got two different kind of GANSes that have a sort of an opposite polarity. So it pulled some of it up, but then the rest of it is getting pushed up into the water. Got another container over there with water that's all orange. I put the magnets on the top of the container. I don't know whether that really will work. I thought maybe I could push it down. So anyway.
I want to jump in here and ask you a question, Mario. Do you know of the metal bismuth? You know what that is?
But I don't know.
It's right next to lead on the periodic table. It's the one to the right, so it's a little heavier than lead. And it is paramagnetic. When I mean paramagnetic, it repels either pole. And so that might be something you might find fun experimenting with is a bismuth GANS. I don't
wonder where I bought that in Shanghai.
Yeah, and you can buy bismuth almost anywhere. And you know what's one of the funny tricks that they do with it is they heat it, and then as it cools, they make these beautiful crystals out of it. I don't know if they're really crystals. So you just look up bismuth on the Google and even YouTube it, and people will show you how to make the crystals. And then they do little experiments where they will melt it and put it, because it melts fairly easy, and they will put a magnet in between two plates of the bismuth, and it repels it, and the magnet will sit there and levitate.
Huh.
So I was just throwing that in for your particular interest, because
Sure.
You had questions there in that regard.
Yeah, it's Lee here. I was getting a greenish GANS of a nano-coated bismuth and a plain bismuth piece. So
you have a GANS of bismuth.
I think I do.
Have you tried to see if it reacts to magnets, see if it reacts to other GANSes or to each other?
No, I haven't. It's still, I haven't even watched the GANS yet, so.
Huh. Yeah, I mean, you see where I'm going with that idea, right? Try to get motion. Because if you can make GANSes react with motion, like magnets, then it'd be very easy to line up, you know, a circuit where you get perpetual motion, wouldn't it? Okay, thank you.
I also, Mario, I had to, when we were talking about the battery charger and the pencil, for the graphite in the pencil or the carbon in the pencil, I think that's worth experimenting with, so I'm going to go ahead and do that. I'm going to get me a small trickle charger, and I see that I can buy one for around $20. That's not too bad. And then I thought I'd use a carpenter pencil, because you can kind of crack those open and get a white flat piece of graphite out of it.
Well, the main reason I brought that up was because my neighbor, the guy I was saying, you know, you got to learn how to make these GANSes and stuff, was really afraid of the nano-coating process. He didn't understand it, and it eliminated a fear factor and gave a very easy positive result. True, it's a mix. It's not, you know, it's not ideal. I mean, but in a
but you got to ask the question: ideal for what?
Yes, exactly.
If it works for that purpose, and what you say, there's more than one person who's afraid of caustic.
Sure, I mean, I was afraid to nano-coat, and wisely, when I was, you know, in hotel rooms where I can't do it in the bathroom, if I have an accident, burn the counter, which I actually did when I started doing it in July. But the flats they put us in instead of a hotel room, it already had stains and it already had some broken tiles. And I added a few stains when the caustic ruptured in the container. So I mean, it held me back just because of the nano-coating. If I'd have known about the pencils, in a way, I probably wouldn't have bothered to learn how to nano-coat it. So it's not necessarily a solution for everything. But at the end of the day, like this woman who's, to nano-coat is an art. It does take some experience, and she's got her first chemo Friday or something. This guy in the first day got more gans than I got in a month. I was like, wow, okay. He just stuck them in, plugged in the battery charger, and the next morning I showed you how many hundreds of milliliters of really nice fluffy CO2. So she could start drinking that water. She could do it tonight and have the clean, clear water to drink right after her.
Yeah, and Doug gave her the trick on how to settle it quick, and that's put a vibrator on top of her container, and an aquarium air bubbler vibrates pretty good, and so then she could clean the salt out fairly fast.
Sure, right. Actually, the CO2, to me, I've always found settles the fastest. Right, the CH3 takes the longest. I've always noticed. So, the CO2, if she gets a little batch of it, right away, she should be able to get it washed, in 2 or 3 days, pretty easily. Even the old-fashioned method, leaving it sitting. But anyway. Yeah, I'm gonna fool around with this, and maybe I see if I can find some bismuth somewhere in Shanghai. So thank you.
I gotta ask Lee a question. Lee, how did your plasma generator that has the 4 jars, one in the center, and the 3 coils around it? How's that working for you?
I'm nano-coating up another set of coils to do it by that different blueprint, and they're still in the nano-coating bucket. So I haven't got that done yet. For getting the lead out of pencils, if you soak those carpenter pencils in water for 3 or 4 days, they come apart, and you get the lead out without breaking it.
I have just determined that my CH3 is in fact rust water. If you turn on the video, you will see what I'm speaking of.
Sorry, you're saying it's what again?
Rust water.
Rust water.
See, I used a bolt, a steel bolt or iron bolt in my processing. And right now I have on the screen my jar of what's supposed to be CH3, and I have a super duper magnet attached to the side of it. It has pulled all of what appeared to be the gans over to the magnet, which I can only conclude are probably rust particles at this point. The only way, of course, I'm going to know is try my piece of iron in a baggie and make some more to see if there's a contrast, so to speak.
Well, this is interesting. What are the experience of others with the CH3 gans and magnets? I've had experience where I didn't have anywhere near that amount of bulk material, but just a tiny. Is that sort of blackish looking that's sticking to the magnet?
Yeah, see what we got here?
Right. Yeah, I think that black would be more the black iron oxide.
But it's strange nevertheless.
Yeah, but you remember, I don't know, a month or 6 weeks ago, I was holding the magnet to my gans And it was, I was pushing that gans around, and now I don't seem to be able to. I'm not sure what's happening.
Yeah, it's interesting. So,
but all of the gans that I was pushing around, when you pull it up to the side, it is this fluffy, red, almost translucent. I mean, it looked to me like it was the gans I was moving around. It's not black. I mean, it would get dark and you know, in the bottom of the container, but you pull it up, up the side with the magnet. It was all red, very, very red, no black.
mm-hmm.
So,
how did you make your gans, Don? In this case, the CH3 gans.
I took a bolt like this one.
Mm-hmm. Yeah.
It's a iron type of whatever, and stuck it in the water. You know, put the leads to it. And now that I've magnetized what I have, it sure does look like it's iron filing, so to speak, that I had in my jar.
Yeah, that's one of those black bolts. Rick, do you know what that coating is on those steel bolts?
That one started out black to start with. It was a Allen head black bolt. Is that what it is?
That is correct.
Yeah, it's a special, I think it's a nitriding coating. You'll see now that they sell these toolkits with sockets and wrenches and so on that are the latest fad is this new black coating. So instead of chrome plating, they do a black or nickel plating. They do this black oxide coating on the tools, but unfortunately, why they're promoting it, why it's the latest fad, is because it's a cool black color, but also it's a cheaper process. It's a cheaper industrial process in order to get a coating that doesn't oxidize so easily into the rust. But what I found when I bought one of these toolkits was that it came off in my hands. The black coating was coming off in my hands. And not only that, it had sort of a waxy, oily coating that comes along with the black coating. And my skin is very sensitive, and right away my hands broke out in itchy bumps from these tools. So I returned the toolkit, and I wrote a letter to Stanley Tools of Canada and told them exactly what's going on. And this is outrageous. They should pull these products from the market. Instead, the market is totally flooded with these products over the last 2 years. And it has, well, actually, that was about more like 5 years ago when that actually took place. That's when they started making these black coating tools. And I thought, well, I'm allergic to nickel, so I wanted to try some other tools other than other than the nickel coating. I want something that's, they'll try these black coating. And it was terrible. So I recommended they withdraw it because there's a lot of mechanics that have skin issues and it's going to cause havoc, just utter havoc among all the mechanics out there. They're going to end up getting skin afflictions and just total health problems from these tools. So I'm not real happy with that whole concept of black coating on iron. I don't think it's a proper way to be doing things, but it is cheaper and they'll make a ton of money off them, that's for sure. Anyway, it's my little spiel about that. But so we have the difference between the black and the red seems to be somewhat important here. I mean, I do know that the black iron oxide, for example, when you do gold panning and gold prospecting, there's almost always iron found with the gold. And in certain streams and certain places of the world, there'll be a lot of iron oxide, this black sand they call it, that it makes it hard to pan out the gold because the black sand is so heavy. And so they have different processes to get the gold out, the fine gold from the black sand. And one of the processes is you use a magnet on this black sand and you pull it out of the, out of your pan or out of the process. And some of, but not all of the black iron oxide will stick to the magnet. And it'll be anywhere from 10 to maybe 50 to 80% of the total black iron oxide that you get in the black sand. So some of this black iron is magnetic and some of it isn't. And then we have the red iron, which is another category in itself. The actual particles of red rust, they'll stick to a magnet, but I'm not sure about the fine actual nanoparticles themselves, whether that's true or not when the iron eventually turns into that iron oxide. So, it's funny, I guess we have different types of materials and so on as we go along. Now,
types of cast iron.
Yes, right. That's
even
the real iron.
Even if you
closer.
Have to break a skillet.
It's closer to the real iron. Yeah, that's probably not a bad idea. A skillet's closer to real iron than a steel bolt, which is got quite a few other additives to make the alloy. So, yeah, interesting. There'll also be a higher carbon content in the bolt. Actually, there's a fairly high carbon content in cast iron pans as well. I think it's higher than bolts. Somewhere up around 10% as I recall. John would know more about that. So,
it's been long. I'd have to dig into my books.
Yeah. Okay, I had a video here I'd like to show that's from Theodore, I believe. And it's about the nano-coating wire during GANs creation that we spoke of earlier. Let's have a look at the video and see if we can get something out of it here. It's about 3 minutes long, 3.5 minutes or so. Okay, let me share the screen. And let's see if we can get the sound to work one way or another here.
Good one. Appreciate your time and love you all. God bless.
Oops, what happened there? Let's try that again.
In some of the more recent Knowledge Seekers workshop videos, as well as the Plasma Reactor Group videos, we've noticed some questions coming up about the potential for plasmatically coating nano-coating wires using electricity and plasma. We believe that we've achieved this using cell phone chargers making our GANs. It appears that the negative wire of this cell phone charger has turned a dark color, almost a lighter black, the powdery black, like Mr. Keshe described the plasmatically coated wires. As a control, we found the same cell phone charger, never been used in GANs creation. The negative terminal is still very shiny copper. These cell phone chargers are ZTE adapters. They run at 5 volts, 700 milliamps. To create our GANs with these cell phone chargers, we've used Radnor copper-coated gouging electrodes, 5/16 of an inch, 1 foot long. Stepped on one broke it to this length accidentally and decided that this was probably a pretty good length for making our gans. It exposed the inside of the carbon rod. And using a technique that we learned from Don and John in Carrie Ellis's video, we dissolved the copper from the electrode by placing two of those electrodes, one on the negative, one on the positive, and the positive electrode, the copper coating dissolves. Over here is the actual electrode that we used that copper coated those wires. Here's the actual piece of wire and alligator clip we used in our GANS process, and you can see the negative wire is very well coated in this on this wire too, where we stripped it back. We in order to figure this all out, we had dissolved the copper from the electrode, made ourselves a copper electrode, like we heard it was good to make GANS with. Made a zinc GANS with that, a couple batches actually, and the copper GANS, a couple batches of copper GANS with electricity, and we decided then to add in the fan between the wires to make more of a CO2 GANS instead of a zinc GANS. So when we stripped that insulation back, we saw that the wire had become dark like that, and decided that it is possible to create a nano-coating on the negative wire during the GANS making process when using carbon electrodes. Our ultimate conclusion is that the plasma flows up from the GANS water back into the wire during the GANS creation. So we hope this can add to the knowledge and people can attempt to experiment with this technique and see if they can duplicate these results and attempt to create a plasmatically coated, nano-coated wire. Appreciate your time and love you all. God bless.
Okay, any comments or questions on that little presentation?
So, well, that was pretty good, don't you think?
Yeah,
now I gotta go check some of my stuff out. I didn't get it all, so I'm gonna have to replay it. I was busy here with my grandson, so it would look like you would be able to take the size of wire that you want for your experiment and just cut it in length, put it to your alligator clips and attach it to your rod. Now, I missed the part where they were dissolving the copper off. So I'll have to go and look at that. Yeah, but
he didn't. I don't think he showed the dissolving, but he showed just the setup itself of the.
Why did he want to dissolve it off rather than mechanically take it off?
I'm not sure about that. I think that was just a way of doing it, I guess. Someone else described the way of getting rid of the copper by doing it that way.
Okay. Oh.
There's the setup with the rod itself after the copper was removed. So we might have to get more clarification.
That's a YouTube, isn't it?
Yeah, it's from the collective.
Is there a link on it? Does anybody have a link on that? You can put it in the chat.
Yeah, let me put that in the chat. I think that's it. Let's just double check. No, it isn't. Okay, I'll just do the whole link.
Yeah, maybe you can put a bunch of wires in parallel and nano-coat a bunch of them at once.
Just a minute here. Copy, and we'll put that in the chat here. Where did the chat go? There's the chat. Okay. Oops, that's the wrong one. It didn't copy through properly. Let me try that again.
So if you're making a bunch of those plasma ones with the 4 bottles and the three coils, and if you design your system, you know you're going to need some stranded wire, so you would cut as many stranded wires as you need for that system, put them in series on that rod nano-coating, plasma nano-coating system, and see if you could nano-coat a bunch of them at once.
Mm-hmm. Right. Okay, let's put the link in the live stream as well for people there for that video. You can have a look at some of the other videos from the collective as well there.
So another thing you might try is see how well it nano-coats a solid wire rather than stranded.
Yes, that would be interesting. And Theodore adds in the live stream chat that old horseshoes have good iron content. And hey, you could get lucky too. Lee has something he wants to show. Let's spotlight Lee's latest and greatest here.
Just for your information, I think you mentioned you had some of these pool light balls. They're an acrylic sphere, about 8 inches thick. They're nice and solid, but this motor here, when it's rated 3600 RPM at 12 or 24 volts, I push it up to 30 volts, and my ball fell apart.
Sorry, it was how many?
It blew apart. So
tell me again the RPM at 24 volts.
3600.
3600 at 24. You put it up to 30, right?
Yeah, so I'm figuring it was spinning over 4,000.
That's
when
about 25% more. Yeah, about how much did you say? 4,500 or something?
I wasn't measuring it, so I'm just going off of what the motor was rated at. So I would say keep them under 4,000 if you're going to spin these balls.
Yeah, I was probably going. I figure maybe 4,500 with that voltage.
That would be my guess. Yeah.
Yeah, that makes sense. Well, that's about the limits I would push for those acrylic too. Putting them up to 10,000, you might as well just put a firecracker in there and let them rip. You know, it's about more fun.
Yeah. I still haven't found the center ball that was in there, but I imagine it's floating around in behind something or under something in my shop somewhere. But
oh, is that right? Yeah. Well, that's good information. I think for safety, those acrylic balls are just not the way to go. Polycarbonate is about I think it's 100 times stronger, something like that. It's incredibly more different in the way it comes apart. It doesn't crack and split up in sharp pieces all over the place. It just tends to bend and rip rather than fracture. So polycarbonate's a much better way to go. But they're hard to find. It's hard to find a good polycarbonate ball compared to the acrylic ones, which are quite popular at Christmas and other events like that.
Yeah, keep in mind also that the diameter matters. As you go up in diameter, the G-forces on that ball go through the roof really fast.
That's exactly right. It's I think it's with the diameter squared is the way I remember. So if you have a 1 centimeter ball, a 2 centimeter ball will be 4 times as much forces on it than a 1 centimeter ball, for example. So yeah.
Anyway, guys, I got to get up in the morning, so I got to get out of here. Thanks, Rick. Awesome discussion tonight.
Thanks a lot for your input as well, John. Appreciate it. And okay, so So I'm thinking maybe I'll shut things down here, but maybe we'll continue for a minute or two and wrap things up, or if there's some additional questions. Francie says, Mr. Keshe in his everlasting battery lexicon says, the energy of the GANs gives energy to the battery. So if the GANs nano-coated the wire of the charger that is used to make the GANs, wow. Yes, that's right. So that's interesting. Okay, any other comments that people want to get in here at the end of this great meeting?
Yeah, I think your link to that YouTube is kind of messed up.
Okay, let me see. I had the feature video or something. It still works.
No, I just connected to that. It's playing.
Let me just
Reactor.
let me see here. If you just take off the
Some of the more recent
I see.
knowledge seekers workshop video.
I'll put it in as the straight link without the feature equals youtube.be, and that should work better for you, but it still should work on the other link, I think.
Well, you made me happier, so I'm really happy now. Thank you.
Okay, thank you, Danny. Let me see, just get the other one in the other chat. I have to spell it differently, so it'll go in. Let's see if that works. Yeah, so it's in the live stream. Alright, any other comments, suggestions, ideas, or presentations before we wrap things up here?
So here's Martin. You hear me?
Yes, I'm going to have to mute you, Danny. So go ahead.
Okay, I just want to say about the hydrogen and carbon. I saw yesterday a presentation from other peoples, and so they create the program like with hydrogen in the layer, in the first layer, in one layer of carbon, you can quasi program the movement of the carbon by the hydrogen. You know, the hydrogen makes then the layer magnetic, and then you have the possibility to lay down the carbon in small places, and so this is will be this is important for this technology too. You know, I mean, normally I think in nature the hydrogen will go to the carbon and make these by themselves, and so it's like an automatic process that we also guide by our thoughts, by our motions, and this makes then the carbon so flexible and so powerful, and also by the process when we create carbon, and when the carbon becomes magnetically by the hydrogen, then you will have this effect also by, when you try this with your magnets. So it can be that the pieces that moves around is the carbon by themselves.
Possible.
Just, contact with the hydrogen.
Martin, was this on a YouTube presentation?
Huh?
Was this on this presentation? Was it on a YouTube?
I saw yesterday. I don't remember the names about these thoughts or these points, but it is a study from an official source. You will find it. I think maybe I can find it back, and then I can give you the link for that. And the other part that I want to talk, that I like to share with you, is I saw your presentation last week but I could not come in to the session. And it was about the Lakhovsky oscillator. I, for myself, worked with that from now maybe a half year. I came in contact with that. A neighbor of me, he gave me his own, it was not his oscillator, but it was a therapy machine with high voltage control setup to make those therapies, how they did it times ago in France. And so when I saw the machine for myself, it was, I saw that idea from back when Keshe talked about how to steer in a 360-degree environment. And so for me, I was lucky, or I was interested to use that for myself to try it out. And when I did it, I could really steer the elements in the sky, because it was a multi-element oscillator. So yeah, that's it. I saw the power of this oscillation tool, also without any electronics involved. Just that form of you can say, the form and the balls, they make this powerful oscillation. And so I think this is the oscillation from our eyes, or from everything that goes, that will make these processes in the nature. And so I had a really special time behind me just to learn how to handle this therapy tool.
Yeah, it's...
Another point, when I work with the microwave to check out my things, so to see how it how they react to the microwave. So I saw that the water then as it reacts, as it turns the copper black, for example, and then you don't have this problem with the vapors in the systems, like the gans-coatings and stuff like this. So the water will go to fire, and then it coats also the forms, and it coats back the copper too. This was for me a help to create the things. Okay, I hope you understand it. It was clear or not?
Pretty much, I think. Any questions from anybody on that? I'm not quite clear on how you worked with the, what is it called, Lakhovsky or wherever it is, the coils.
Lakhovsky.
Mm-hmm.
Yeah,
how did you actually work with them, or what did you, were you using it for healing, or some other thing for energy?
The Lakhovsky oscillator, it is, you could say it is the source. Also, it is for me, it is a very old technique to work in the medical section. back then. You know, when you read about Lakhovsky.
How is it spelled again? Can you help me and I'll write it on the screen here?
Lakhovsky. I have to.
You'd have to look it up. Well, never mind. It's okay. Lakhovsky oscillator. I'm not sure. Maybe we should give people more information on it. Let me just see if I can find it here.
Now here I don't have pictures. Maybe what I can do. But you talked about last week.
Okay, I got it. It's Lakhovsky
oscillators.
Yeah. Let me see here if I can do a text. Oh, wrong color, Rick.
This multi. This kind of.
Yeah, it's a multi-wave oscillator. So it basically, he talks about converting, or one way to use it is to convert the Earth's magnetic pulse into electrical potential energy, which charges your cells, for example. And some iterations of the same basic oscillator, they make it on a micro scale as well, like
yes.
Tiny wee shapes, the same shape. And this shape with the C within a C within a C, basically, is very special. It's a self-charging, self-oscillating system, because the lengths of the different C's are in resonance to each other, so they basically are multiplying. If you have a little, for example, if you had this center one, let me get my drawing tool here. This center one started vibrating here, then that makes the next one vibrate, and the next one vibrate, and the next one vibrate, and so on. On the other hand, if you make the outer one vibrate, then it makes the inner vibrate as well, and it actually amplifies it as you go down and so on. So it can be both a receiver and a transmitter, and it can act as a sort of a bridge. It picks up waves, essentially, so it's good for radio antenna, for a certain frequency, if you make it in a nano level, so that these are etched into a copper substrate or however they do it to end up lithographing it or something. You can actually make tiny wee little guys like this and put not just one, but you have one and you have another one beside it, another one beside it, another one beside it, another one under and under, and you have a complete pattern that's etched into a large sheet, but large, and just the whole sheet still may be only nanometers by nanometers, basically. So they've microsized this concept as well as macrosized it. The original oscillators were, some of these circles were up to 6 feet tall or something like that. You can, there's images available on the internet. I don't want to post any because they might have copyrights. I haven't checked them out yet. But if you look up Lakhovsky oscillator, you'll get all kinds of information on that. And I think some of it could very well be relevant to our current situation. It really does make sense the more I look at it here.
Is there any aperture voltage that come off there? Can you determine frequencies?
You know, the point is you have such a high pitch and then charge in your surroundings, even in the skies around you. So for me, it was really to see the power in the sky here, to create the colors I like, the blue where I liked, and to also to hold them on places. So you can really steer the sky or light up the sky or make them dark with this kind of just this pure therapeutic tool. And I mean the same basics are behind the magravs, the magrav system. To create this field that can oscillate through you, so you can steer also these elements, how they can pass your body, how they can pass your or go out of your body with this kind of steering wheels. I would say for me, I can more understand it, and you can really do the same thing. I think it is the same technology behind, just another source or another way to think about and to see it, and then to go to the micro or whatever. And so, but it was really powerful for me to experience that, what the power then these bring around me. I can create right now, even with my own version. I did versions now just because the other one was too strong for me, too powerful. If you have heavy elements like the supply, the lead is inside, and the zinc and that stuff, and the gold was on that too, and so I had really powerful, dark nights and storms and whatever.
So you're saying you had a lot of heavy metals in your body?
No, it's just if you work with heavy metals inside these instruments without, I cannot say, the original tool that I used to steer the heavens, so I say now, it was just the pure elements bound around those copper wheels. These are Lakhovsky used these copper tubes. Maybe I can make a video that you can see what I talk. I mean, you see it here. The design is right. What I have too.
Are these nano-coated? Are you nano-coated materials?
I mean, normally the copper will coat themselves, but the original Lakhovsky machine was not accepted. Was not nano-coated. This I cannot say. I mean, there are so many different.
Is this design the way you got this drawn? Are those coils, or they're just pieces of nano-coated copper? I'm not exactly sure.
They're just you take a piece of say copper tubing or even copper wire and bend it in a circle and put a little ball on each end.
Right. Okay.
And that's basically it. And what ends up happening, it's interesting because we put a ball on each end. It creates a field between them. It's able to interact between these two balls. And what happens is one will develop a charge. There'll always be an imbalance. So one will have more of a positive than the other one. One will be more negative and one will be more positive, or in that realm. Maybe not plus and minus, but maybe plasmatically or whatever. In any case, it'll be unbalanced. So that creates a flow back the other way. And that creates another imbalance. This becomes plus, that becomes negative. And that creates the flow back the other way. And pretty soon this thing's flowing back and forth and back and forth and back and forth at its resonant frequency. because it can never be balanced. It's impossible to have a perfect balance at these poles.
What are those balls made out of? They're just copper or whatever.
I think they usually use the brass balls, don't they, on the end of the copper?
It doesn't matter. Try everything, you will find completely different performance then, you know. The form then gives a form. Also for me, I can create the forms of the clouds outside, let's say it outside, with these balls. Now I have like a brass tube, and then I use LED round ends to make the end, and so I don't have the same how it calls. Now it's not so heavy. Before it was too dark for me, too strong then to guide my surroundings, because you are also responsible for what you're doing around you. And with these machines, I would say also with the Keshe technology, we are also we are also in this weather manipulating business, you know. You will right away influence your neighbors and your surroundings. And so it is important that when we work with these therapy tools, that we really observe our surroundings, because you create then the forms of the clouds and the colors of the clouds, and especially with these endings, you will find that you create also the form. You will create a stable form of a cloud, a dark form of the cloud, or a white cloud, or even not the cloud but the light. So I see when I use these LED ends, these are round LED ends, so round balls, light balls. This is not just to symbol the light for myself, to steer it, but it creates the light from the color. You can light them up later too, but it's not important, because you have so much power then in the skies dispersed around you.
Yes, I think people have used high voltage onto it and caused plasma around the whole device.
The high voltage is just to see the sparks floating around you in the therapy sessions and stuff like this. But this is not important. You don't use some power of so you don't use these high charge control systems. It will go anyway.
You haven't coated this with GANs or anything either, right? You're still getting those effects.
In this situation, I don't have the GANs coatings involved until now, you know. But anyway,
you were having the effect before you had the GANs as well, though, right?
Now I'm still in the process to build it up again, because I had to really tear it down. It was too heavy to steer. Also, I had really powerful storms then in the springtime, and so I had to really dark weather. And so I had to tear it down, because I have no one who could help me how to move it other way. So I tear it down. I put it then in a round reactor to disperse the materials. This is a special story. I don't have to go in there now. But I think to understand, you know, the technology of Mr. Keshe, or this new plasma technology, it helps a lot to, because I think the Keshe magrav units, those are just smaller versions of these big ones, and the oscillation process makes it so powerful. And you can use every element there. You can use every element. Here at the Lakhovsky used this French guy who made the version I used. He had this multi-element oscillator. He wound the elements that he liked to have in motion. He wound around the copper tubes. You know, these are soft copper tubes from the soft copper tube from these floor rolls. So you have then every round. You can say is then another diameter. So you can create your steering wheel, how I call it, and then with the ends, then you can create, also without ends, you have then, I can create lighting in the sky. Also without ends, you have the oscillation, because you have the circle not completed, and also the magrav that we work with is a, you can say, oscillator. It's the same form. It's just you have now more copper around, but at the end, the power is the oscillation between two or more forms of the same power, of the same frequency, you would say, and then so I see also the fruits when they come in a shape with special elements inside, and the form, they will find somehow another fruit who has the same shape and make then the connection, and then the dance between those tools in the through the earth or through the sky create then these powerful beings that we represent by ourselves, our eyes, our two eyes. They are nearby others by themselves, and then we have this oscillation going on to the space up and then to the ground too. So I see these in any places, and I think so. Yeah.
Well, maybe we can get into this a bit more in the next workshop. Get some more information and some pictures that aren't copyrighted and so on. We can work with. There's a website I put into the chat there that was suggested by Cleve in the live stream, and I think I might need a www in there, but it's the basic. I'm not sure if that goes through or not. Let's see.
I think that the information about this technology is too old. It not will be affected some rights.
I was able to click on that link, I believe.
Yeah, it seems to work. So that's...
right now, Martin, you in the process of making one, or you don't have one made, or
I'd like to show you. Can I show this?
Yes, if you know it. Well,
yeah, go ahead. If you can put your video on there.
You know, I had to pour the original. I had to pour apart because yes, I had the problem with the weather, so I had to make it softer. Can I show this?
Do you want to show your video or show a picture?
Video. What can I do that I can show the video?
You should have a start video symbol at the bottom of the Zoom meeting. There we go. Yeah.
Okay.
Let me get you spotlighted here. Okay, yeah, we can see you there.
You see that?
I see it.
Now
yes, now we can
see.
Okay.
This is one version, you know. You see, this is the original. the original cross was from this. This was the machine. This was the original one from France, copper, and then the original had then the elements round around to make it more stronger and to have then the other elements on. Here I have just these light balls. You could say it's just symbolic, but still it works so powerful. And I waited until I can discuss this more with you, because I like also to make the nano-coatings on the copper here to see then that it will have another effect in the sky, also less harder effect in the skies.
So what you have here, you have one copper rings that goes all the way around by itself.
It's just, you know, here, and normally you have then full...
Can you back up just a little bit so we can see the whole... There we go.
Yeah.
So
if you can hold the camera steady there so you can see the whole structure, just hold it real steady so we can see. Thanks, yeah, okay.
With a tube, I had the idea just that I can use different elements, like ashes, like copper oxide, and with different balls, golden, and these are just Christmas balls, you know. It's just to have that you have the form to create these colors then up in the skies and the form from the clouds. Because I saw when I use the round balls, the sky is more stable. If I use more egg-shaped forms, you have more unstable conditions. So this is important to see them too. If you have without the balls, it was lighting. I could lighting the skies without.
Is that a plastic tube that you have in there as well?
Yeah, this is just my version now with the things I had around. You know, it is not. This is not original Lakhovsky technology, but you can be really
you're being creative with it and using the materials you have. Yes,
because I want to light up the sky and not make them heavy, because with the original Lakhovsky it was really it was nice, it was beautiful skies, the color in the sky was really powerful. But to steer it, it is not so, I think, it's also dangerous. So I search solutions that are simple to make, and then, yeah.
So in your research, have you come across a way to tune it to where...
You know, I can now steer with this. Now I have laid it down, and I made it like a little bit... so the outside, I have here 3 of those. This is one ring, this is the other one. Here I have more the blue sand as agent to say, okay, here I like more the copper oxide sulfur. And over there I have a 3rd one. So I have 3 nows, 3 wheels that I can steer. When I change the position of the balls, it will also change the positions of the light in the sky. Or you can say here, I give more the position of the materialization of the elements I want to have positioned in the skies, you know, or in the room. You can say in the room, when you make the therapy, then you can steer with the wheel the place where the newer elements, also the heavier elements, mostly will be where your head is, and then you can steer around. Also when this is up. you can then also position the point where you want to have the flow through, you know. With these, you can position then, and the other one then of the opposite way, you can position other ways, and so you can say, I want to have the flow like this, or I want to have just a linear flow, and the same thing works also for the sky. So when I just worked like this, of the other side too, then the wind would go like this, and if I change that, so if I have it like this, you could say the balls down, the big ones, then it's a stable flow, and if you have the balls up, then you have a labil flow. So then you have more storm, you have more.
Are you a sailor that you can go out? You can go out.
You have to see that this will learn you to sail in the outside.
Yeah, if you went out on a lake and you had this to
you steer the weather around you, you know, and I think the possibility to steer the weather, for me, it is important to
maybe
space.
Sure, maybe in the spaceship we're steering the plasmatic weather. That might be some bad weather ahead that we need to steer through, right?
I just want to say, as for me, it was really powerful, these effects here, you know, around me. And if we work with these magravs, you will see, you will steer also your things around you, the sky.
So I'm going to go and do a little bit of
recipe.
A little bit of recipe here. That copper wire, is that a 1/2 inch or is that 3/8 inch? I mean, that copper tube, is that a 1/2 inch?
Just here is important that you have different
diameters.
Diameters, yes. But you can make it also with the same. It's just these you will find on these rolls, and so you can cut them so that you have every 5 centimeters. It depends how your thing is. You can make it big, small. This is from the bed roast, you know, as a bed. The spring of the bed, you know, the wood spring, and this is a wood plate. And so I made the holes and wrapped it around with the plastic dough, with the strips. This is just to flexible with fix it and take it away. And here I used these glass tubes, Phillips tubes, just to see the effect, how I can steer the light. And this is just my version, you know. I thought I just want to make some who is a little bit different than the others, so I can make different systems.
Perhaps this can inspire others to try a few things. I mean, if you think of it as an oscillator, maybe it can be a heartbeat too for a plasma system.
Yeah.
Well, if you make it small enough, maybe you can actually stick it between the layers of your stacker unit.
Yeah, entirely possible.
I would say the magrav unit is an oscillator. You know, the form that I have, and you can steer it like this. That you have the oscillation, the break here, or you can make it like this, that you have these changing fields like here. But at the end, it is a plasma oscillator, and it is the same. You can use everything.
But there's one difference. I was just noticing it looks exactly to me like a magrav coil, but you don't have it. you've got it each loop feeding back on itself rather than you don't have them connected, hardwire connected the way we connect the Mac.
But you know, in the skies, you don't have these wires. You don't need the wires because it's so powerful and it gives you so much light, so much how we call interaction. You now here on Earth,
the idea of induction, inducting the power.
Yeah, so you're creating a feedback loop for each loop on itself. So it's going around in one direction and going back around, but then it's just going back around itself when you have the other one doing the same thing on the inside. So you've got basically a pulse there. Those two are going to resonate. This is very interesting to me. Thank you.
I was just going to say the cables then at the end, you can have them or not have them. The effect will be different. It is anyway interesting to looking also for other ways to do it. But it is a technology. Huh?
Well, I'm just wondering if the magrav units, what they're really designed to do is to conduct the flow of the field, not creating this individual feedback loops per se, but to conduct the flow so that you can plug in your appliances and things. So that's for that reason. But this is strictly as an oscillator, but it's the exact I think, right? I mean, if you take the magrav units and
if you can get this to oscillate at 50 hertz or 60 hertz.
Well, it doesn't matter, you know, the hertz. Just feel
so it's your like for intent. If you design it for a purpose in mind, then you'll design it for that purpose.
Here's another idea that just came to mind. Let me share the whiteboard for a moment here. If we had the whiteboard, my things, clear that. And if we had, for example, let's look at, say we had our coils. Like normally we have a coil like this, and we have the other coil around it like this.
Not seeing your drawing.
Sorry, I got to share properly here, I guess. You see it there? See the whiteboard?
You can see it now. We can see what you did. Yes, we were looking at the old drawing that you had.
So like the old drawing, you shouldn't see that now.
No, we're seeing it. We're seeing your drawing now.
The new drawing. Okay. So we got the coil. If this is a coil, and they got the inner coil and the outer coil, and normally the connections all come out at one area. What if we did it differently? I'll just do it over here. What if we had one coil set that came like this and had its connections here? And what if the other coil set had its connection out the other way? Out that way. And then perhaps even put a third coil connection around this whole thing and come out this way, so that we alternate the openings, the same as the Lakhovsky coils, which are always opposite to each other. That's what creates the resonance. That's what creates the oops, I blew that one, but
that'd be interesting to look at it for John's car unit as well, because he's got some ends that are not connected to anything.
That's right. And like,
well, yeah, and imagine this. Imagine that for each of those magrav coils, instead of connecting them to anything, you put a loop on each end, so that now each coil is just going back and forth, back and forth, back and forth. It won't work for a magrav unit for your house, but it's a plasma oscillator.
Well, you've got to test it out to see if you can get it, because one of the things we're after here is an off-grid. So you look at this and you began to analyze it. Maybe you can test a few things, and maybe you'll just get lucky from one test to the next.
And you know, they made these, like Rick said, you know, they made microchips with these kind of oscillation technology to create also power. You know, there was a company that made some small chips years ago who had that ability too to create power for the grid. I mean,
that's right, and they pick up on the ambient power from other devices and so on. Just there's fields around us all the time, of course. So that's what this kind of oscillator can be good at. It can pick up all the random fields.
And it's like Keshe now, the magravs. You know, if we use this form in different ways. And make it small and big, it will work in the same way. And also difference than when you are in the car. You know, when I used the old one, the big one from Lakhovsky. With these ones, I wasn't with the car, but when I was at the therapy machine, just without the electronics, just the wheels, I laid it in the cars. You know, in the feet part and the back seat, and I made really a heavy sky here for the farmers around me, direction of the Alps. So it was really there. It was really black. Here I could light up the sky. Couldn't make it blue, but they had really dark skies, and so I was sure that I can steer also there, also lead their sky up. And I drive with my car and these two wheels in the ground. And that when I drive there in this direction, the skies was like they light up. It was like you go with a tool, you know, scratch the sky. So I had really, really powerful light. Some of them. Yeah, it was a powerful light in the sky, and I saw my tool in the skies. You know, I saw the form, I saw the structure. It was from that utility, also that wheel. These two wheels charge the sky then up. That I think you cannot measure maybe the power that comes from these wheels, but is so unbelievable. Even dark, black, pitch black, and then a violent storm. What more you need? It's just unbelievable. I think you will have the same experience with the magravs when you use them in the real world. You don't need any power grid. You know, this is so powerful stuff. And now I have made it like this, that it's a little bit more softer. You know, I will try then. The next part will be to make it black, to make it, or just carbon. Just I try to carbon also the plastics. Maybe it will be more easier than the. I know the carbon and the copper. This is still a very powerful connection, and gives powerful signals also to the sky. So I will try to make it. With the plastic.
One of the things you can try there, Martin, is to put a smaller tube inside a larger tube of your copper tube. Say you use a 3/8 tube and you put a quarter inch tube inside, so you've doubled it.
Yeah, that's an idea as well. Gordon asks, he missed the audio. What's inside the balls on the ends? Will you review?
You know, there's nothing. There's just you could say this.
Like
It's
on,
just,
on the original, it was just a brass or copper ball, basically.
Oh yeah, original it was brass. Not it's not, but the mostly from the France side I made it with brass. Also the balls you can order copper or mostly today you become brass from the internet to have the ends, and then you can have different diameters.
Yeah, those look like LD. I mean, LED.
This is LED.
Yeah, an
More
LED light.
Because I like to have white clouds. my
Actually, under ideal circumstances, especially if you run a high voltage into one of those coils or one of those circles there, it could actually light up those bulbs. Those bulbs could light up. It's entirely possible, even from ambient.
You know,
imaging.
this thing, I use it now to steer the sky too here. So even in this configuration, you guide because you guide the room here inside your house or inside this room. I make the charges outside. So I create the different elements in the space outside.
Well,
this I saw. I could also with the two wheels, when I had one wheel up like this, like in the therapeutic formation, and the other wheel laid down. So then you have like it is more fixed than the movement. Here now you have the oscillation. When it's like this, it's more stable oscillation, and you will have more flashes, also more light, without the bad weather, but it's a high charge. If you have more diagonal, it is more it mixed up. So you can more mixing and give the weather a chance to go out, or you go in. With depends how you lay down your tools. But you can fix the elements in the sky. Then, if you have elements here, and if you have around here copper, around here gold, whatever, and you can steer the elements then in your surroundings with this the very same tool, and fix it on place. I had one day, the first time I tried out like this, and I could held the elements for hours on the same place. They could not move. It was very strange to see. I show it to my neighbors, or I walked around in the village. It was stable. It stays on place.
So you start to look at this again to Rick and Martin and Mario, you when you were trying to create materials, this might be a way to control the plasma fields in such a way that you can bind the field to where you create the material you want.
Yeah, you can fix here. As this was originally, you have the elements around here. You can deposit here, or you make the ends, the clouds, where you would like to have the focused point or the discharge in your space around it. Then you can steer it and control it with your hands, because the mind is not so strong. You will not remember your thoughts before, but with these you have like a remembering, and it will stay. It will. For me, this is steer wheel of the hands. Yes.
When you say elements, you're talking about ganses, right? Is that what you mean, the different ganses?
The ganses, we are out of ganses. Gans is a part of nature. You have to understand how nature works, and it is just now for us to remember it, or now we can remember it. Before it was not allowed to think on those things.
Well, as
Lakhovsky.
Frangie mentions in the chat, in ancient times they used standing stones with iron and silicon inside, maybe more, to have influence on the weather.
Yeah, we have, you know, the what I should say. When I work with the weather, also when you work with the sun, if you make sun gazing, if you work with cloudbusters and stuff like this, even every tree, every church tower is a cloudbuster. It's made for that. It's made to, you know, has the balls on the top. Like the Catholic churches mostly have these four. So the Catholic churches have these.
Well, I wonder if that's the purpose of the steeple, is to make it for good weather so everybody will attend church.
No, but just to know that we had all times in the technology, also in the, we had the elites or the people who was in this who had to guide the weather, you know, and the towers, these different church towers, they are made for that. And the clock, then the clock is the capacitor who can hold back the charge, and then when you have the bing bang, if every half hour or every quarter hour discharges that charge to the surroundings. And I think it is not new. It's just we have forgotten it. So, but we have it anyway. We have it still around us, the towers and whatever.
So what do you got to your right there that you're showing that something's spinning there?
This is just from these are heavy things like gold or like you know, heavy stuff that I don't want to have just in the air. When I stop this will give me disturbance, and if I spool it around, I can disperse things around here in the room and outside, and steer it with the velocity, with the, you know. This is like an old.
It's like an old phonograph player.
Yes. Here I have just the elements that I don't use, but I want to have dispersed it in the sky, so it's not just lying around and make mess to the skies here. In this moment, I'm really sensible about it because I know I'm responsible for it. What happens around me here, I have to search. This was this I have. You know, you can also change when you change the glasses here to white or dark. You will find completely other skies around you.
Okay, I'm going to have to wrap things up here now. Yeah. I'm starting to. My leg is starting to tell me I need to stretch it.
Thank you.
But thank you very much. I appreciate that, Martin. That was great. A lot of people like that topic. So maybe we'll skip back to that again in the next workshop or some of the following ones. I'd like to find out and experiment more with this idea of the oscillation between the coils. I think it might be important as part of our magrav design.
Force, you will see.
Yeah. Okay, thank you. And Francie has just a couple of pictures that I wanted to show here. So I'll mute your video, Martin, and just show the. Do a screen share, and we can briefly look at that, and then we'll have to wrap things up here. She shows her magrav coil. This is over the battery, the way I understand it, and you see the battery aluminum foil and GANs blanket around it, kind of. And Francie, did you want to say something about that?
Yes, this is the first photo. And if you can see, I put from the inner coil, I put to the plus, and from the outer coil, I put to the minus. So I changed it later because this way is not working. I thought it was infinity. So I turned around. The little one is going to the minus from the battery, and the red one, the outer coil wire, is going to the plus from the battery. And then I have 6 volts. It is from the solar panel. So the other wires are going to the solar.
Okay, I think that one thing that might occur is that how do you make the connection between the nano-coated to the battery? Because you have to be very careful not to crush the nano-coating when you connect to the battery.
So I turned around the iron connection, and then I put the red one on his how do you call? It is a female and a male. So I put the female to the male, and the nano-coated wire I turned around.
Yes, but if the nano-coated wire touches the battery terminal, like if the actual copper of the nano-coated wire touches, then that's not good. You need to make a plasmatic connection there rather than a copper to battery connection. It has to be no physicality. So if you tighten down that battery connection, for example, or twist it too hard or whatever, then it'll start a physicality connection, and that'll cause a short circuit. So that connection between the battery and the magrav unit will be very important. It should be like maybe another nano-coated wire that's in a wrapped in a loop that hooks onto the magrav unit, or some other way to plasmatically attach it rather than the physicality. I think that might be the case.
Can I do a spiral and then a little coil?
Yeah, I think that was the way Armin was recommending at one point.
Okay, I can make the coils on it, and then I put the nano-coated wire from the coil
to the battery, right to the battery terminal. Like maybe make a special nano-coated wire from the battery terminal that's already hooked on physically to the terminal, but it'll be the nano-coating that attaches to your magrav unit. It should be nano to nano for the magrav unit. So that might make a difference there too, but it sounds like it's working okay now for you, is that correct?
I didn't measure it this morning, it was too early, I have to do it later. I will inform you, of course.
Okay, keep us posted for next week's workshop, I'd appreciate it. And we got one more picture from you that I'll quickly show here as well, and you can tell us what's the story here. We see some GANs. Can you see that there on the sharing? You should be able to see that now, I think.
Yes.
And, okay, so tell us about this.
Yesterday I was making iron GAN with nano-coated copper and a real iron plate. And then it started like this, and it is still like this. I thought first the iron is copper, it's not iron, but it was iron. And then I said to myself, okay, let it go. I want to see what it will be, but it is really like this, thick blocks, and no other color than green, gray, and a little bit brown.
And what kind of iron did you use?
A really iron plate, a pure iron plate. Yeah, well,
Okay.
I was a mix too.
And you didn't use electricity? No electricity?
Oh yes, I did.
Oh, okay. What was your volts and amps on it then?
The volt was 1,5.
Mm-hmm. And do you know how many amps it was?
Oh.
What kind of battery did you use, or how did you get the 1.5 volts?
I don't know.
Hello?
I was looking for it. I cannot find the charger.
Oh, but I mean, used just a battery, or how did you get the 1.5 volts?
With a charger.
Oh, I see. A charger. Okay, right. Any other input on that? It looks like there's.
Was there a nano-coated copper plate involved?
Yes, a nano-coated copper.
Did you use how many, just one copper plate?
Yes, it was not a plate, it was like a coil, a little one, maybe 5 centimeters.
Did you have more than one coil?
No.
Because the reason why I'm asking is the green color.
Yes, 3, I put 3 together.
Okay, sometimes when you have more than one unit of copper, you will get a reaction between the two coils that give you the copper oxide. It gives you the CuO2 GANs, and that's where I'm thinking of the green comes from. If you had more than one coil that you had in the mix, then the coils begin to react one against the other, and so that's why I think I'm seeing the green. Anybody else have any comments on that?
I think that is it. Thank you so much.
That's an interesting observation. I could go with that. I'm wondering what the salt content is, and how long did you do it to create this?
Not so long. I think it was some hours.
Right. So that's probably quite a long time in terms of electrical and GANs and so on. So. Is your copper plate still look like it's black nano-coated at the end of it?
Well, she said she used 3 copper coils. So my suggestion when you do another experiment, just use one.
Yes.
Right. Did any of the coils look like they had bare copper at the end of it, or were they all still nano-coated?
They were not shining anymore, a little bit green.
Okay, well, try what Denny suggests and get back to us on it, I'd say.
When you start seeing that green on your coil, you can almost guess right underneath that green you have a bare copper. When you wash it off, check and see if it is bare copper. And you set that thing aside, it'll grow back the green on it again, I think. And after you've washed off the coil that had the green on it, just some of this stuff you just kind of experiment and off the wall do things and then observe it to see what happens. But I would suggest when you're making any GANs besides the copper oxide GANs, just use one coil or one plate. Anytime you use more than one, then you have a reaction between the two plates.
Thank you so much. I know why it's not working.
Great. Excellent. Good diagnosing, Denny. Thank you. Okay, so I think we have to wrap things up now. I think that was very interesting, and we had a good time here. And just get my video back up here after getting So many windows. So I'm sure there's a few things we haven't covered and so on. Try to bring your questions back next week. Anyone who wants to send me a presentation or other information can get a hold of me at Rick at spaceshipinstitute.org, and that's pretty much the best way. So people are saying, Doug says, best group meeting ever. Thank you all. Well, Gordon says, agreed, Doug, bravo. Well, that's good input. Thank you, everybody. Yep, so that should wrap it up. So I'll try to get the sound a little better next time around. I'm sure it's not too good in live stream. There's probably an echo happening and so on. I'm not sure what, I'll find a solution for that. Anyway, thanks everyone. It's now Wednesday, September 21st, 2016, and it's been the Keshe Plasma Reactor Group. Thank you everyone for attending and participating. Looking forward to more of these adventures in the future. Alright, I'm going to shut the live stream.